All right. So today we're gonna go through basically what we were doing yesterday, which was fuzzing calculator on Windows, the old school calculator, this one. And we had a couple issues. So first, we can actually look through the bugs that we ended up finding. We found a couple bugs yesterday. Let me grab all of them off of this VM. Actually, I probably should just shut it down if I want to grab the bugs. How's everyone's day going so far? All right. Good, now that you're on. I'm glad to hear that. I'm glad that people are enjoying this goofy little stream. And let me just hop over to VHDs. And we'll just do this / oops. This one. Okay. So we had a couple crashes from yesterday. So this one I actually haven't looked at yet. So this one looks like a... Well, it's supposed to be a null DRF, but it's definitely not a null DRF. Let's see where we are. So this is, I guess, the one that I ended up posting yesterday. I guess I have a duplicate of this. So, there must be a bug in my file naming stuff then. But effectively, this access pattern, the COCO, is basically accessing uninitialized memory in a page heap allocation. So this is an uninitialized memory usage. So basically, when you do a malloc, when page heap is enabled, it will fill in with COCO, blah, 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 blah. And then as you fill it in, obviously the contents change. So when I see an access of this address here, I kind of just assume that it's an uninitialized read, which in this case it definitely is. So we can kind of look back in execution, and we can try and see where this RDX came from, because RDX is clearly the bad value. Usually it's the instruction before. Here we see it dereffing a couple tables. We see that RDX came from racks plus 18. If we look through racks, we'll see that we have like a partially initialized structure here. We have like a couple pointers. In fact, we have this statistics mode VF table. So this is a statistics mode object here. We can see that a couple fields got filled in with pointers. A couple are left uninitialized in the structure, and we have a couple other pointers here. So basically the way that I would interpret this bug is there's clearly a way that you can cause the statistics mode thing to get allocated, and then we can cause it to access a field in there that has not been initialized yet. And I think we're accessing at 18. Yeah. So this is the field that we're accessing. So we could try and figure out what's going on here. Have I considered writing for Xeon like paged out? I haven't. I think this would be, yeah, a really fun thing for that. I love the paged out like magazine. So, and I think this would be right up the alley of like fun and approachable, which is one thing I really like about this project. And let me know if the mic levels or audio levels are too high or too low. I know it can be, it's difficult for me to try and figure out what the levels actually sound like from my end. I should get like an actual streaming setup here. So this is obviously the most promising bug. We can quickly look and see where this the result of this would be used. So let's say somehow we groomed the heap and we got control of this deref. Let's say we had full arbitrary control of RCX. What would happen in this case? Looks like we're going to go directly into this get dialog item function. We pass in, this is the first arg. We pass in this 99 hex as the second arg. I recognize that we could pull this up in IDA, but if we take a look at this, this is going to grab, so RCX is what we control. Interesting. This is, oh, that's the pointer we're looking at, yeah. So this is the actual function. And we control RCX, which is the first argument to this. Let's see if we can disassemble the function. And validate HWND. It looks like we have control of the HWND. That looks like that's what the type of that object is. In that case, is there really anything we're going to be able to do? I don't think having arbitrary access of window handle is really going to get us anywhere. So this bug probably isn't going to be the one that we need. We can take a look at some other bugs that we got. So we got a null deref. This one is in the history calculator. So far, both of these have been in the history calculator. This is really important because this tells us we really need to fuzz that history stuff. Both of these bugs so far have been from history. Thus, we need to really make sure that our fuzzer is stressing kind of that history aspect of calculator. And that's something that we'll just put a little bit of bias on when we're writing the new and improved fuzzer. In this case, it's just a null deref. If we look at where RDX came from, let's see, RDX is stored in RSI. I'm not seeing any obvious path where that's coming from. It looks like it's the second argument to this vector, kind of to this vector function. So let's take a look at, even though it's a null deref, likely we have no control over this thing. Let's say in theory we had full control over the value pointed to by RDX. We know that RDX just got copied into RSI. And where are we at? We are here. Let's see if we have any RSI accesses. We do here. There's another thing that grabs RDX, does some math on it, passes that to another vector function. In this case, these do look like they're actually going to be pointers. Yeah, here we're actually... Yeah, it looks like we have a null deref on a vector object pretty much entirely. Maybe theoretically, we could, if we could get control of RCX in this case, we would likely have an arbitrary right where from where, because it looks like we're going to use all of the pointers and lengths inside of RSI. Or at least we might control what the contents we're writing are the length. So it looks like RSI controls RCX and RDX, which I would guess would be the source and destination. Is this like a reallocation maybe? I'm not sure, but this looks like a memcopy. I don't know what calling convention this uninit copy specifically uses, and I just don't want to look too deep into this bug yet, just because I'd rather focus on getting new and better bugs and get a fuzzer up and running. So help pane we got a crash in. So this one we actually got arbitrary code execution. We're executing data. If I look at vprot of our IP, we'll see that we're executing read-writable memory. So we're trying to execute data. Obviously, these instructions are all bogus. And I think these might actually be strings here. Yeah, there's like PS equals here, which is a string. We can look at what we're executing. This is clearly not code. We've got like 2 pointers here, and we've got a string here. I guess this might not necessarily be strings. Could be a coincidence. Nevertheless, that's in the help pane, which is kind of the help view or the HTML renderer. What else did we get? I think that's it then. And then we had the potential double free on closing calc.exe. Okay. So that's roughly where we left off yesterday. That's kind of like what we got overnight. Obviously, the fuzzer is terrible, and it wasn't really doing anything, and it wasn't scaled out to multiple cores, and it probably got hung up a bunch of times overnight and probably didn't actually do too much. So what we're going to talk about today is making this fuzzer much better. And we're actually probably going to start off by writing a new tool, and we're going to learn a lot about how Windows GUI design works. So if I take a look at Win32Calc, basically my goal today, and it's going to be a little bit more development fuzzer sort of work. There's probably not going to be as much flashiness today as yesterday, but the end result will likely be a fuzzer that is at least 100 times more efficient at just fuzzing. So what I'm going to try and do today is I'm going to try to enumerate all of the actionable elements of any GUI. So effectively what I want is I want to be able to give the window name calculator to whatever application we write today, and then I want to basically get a vector containing all of these buttons and all of the coordinates for all of these buttons. I know that for calc, it's a relatively simple task. We could probably just do it manually, and it would take an hour and a half. But I would rather kind of go the correct way and try to find out how to extract all of these elements from the GUI. More specifically, I would like a differential kind of view of this. What I would like is that when I pop open calculator, it says like, okay, you have all these buttons at these coordinates. They're this size. Mainly because I need to be able to calculate the center of mass of these buttons so I can click right in the center of them. Further, I want to move to a send message based approach. So yesterday we started with send message, found out it wasn't working because we didn't know where all the elements on the screen were, so we couldn't send messages to the right components. Today we're going to try and go back and start to do it correctly, which will be a little bit more work, but it will pay off in the rewards. Then what I would like is that when I switch modes, let's say if I go to programmer mode, I would like to see that all of these buttons get deleted, all of the buttons on this view get deleted, and then a bunch of new buttons get created. And I would like to see these radio buttons too. And if I'm able to get kind of all of these GUI elements, and it'd be really cool if I could somehow figure out where all these digits are, but that one, I don't know if that's going to be possible. So effectively, if I can find out where all the different interactable objects are on the GUI, we can then fuzz by clicking them as fast as possible. Keyboard entry, I don't think matters at all in Calculator in this case. I think we want to focus pretty much entirely on clicking on all of these buttons. It doesn't have to be clicking. It could be injecting some message that says that it's been pressed or whatever. So we've got a couple ways that we can approach this problem. I don't really know how GUI development in Windows works. We'll take a quick look. I'm sure we can figure it out in a few minutes. So if there's an API in Windows that allows me to enumerate all of the objects that are currently rendered on a window, like all the sub windows or all these buttons, then we're probably going to want to go that direction. It would just be cleaner, a little bit simpler. However, if that API does not exist, then we'll go a different route and we'll take mesos and we'll put breakpoints on the calculator application in the respective locations where buttons are created and removed, and then we'll track it from more of a breakpoint perspective. So regardless, we will find a way to find out where all of these buttons are, the coordinates of them, and then the size of the buttons. It would be also nice if we could maybe get the text on the buttons or whether they're enabled or not. So yeah, that is the goal for today. And the end result will hopefully be a fuzzer that effectively will be able to work on any GUI application, and it will click as many of the buttons as possible in whatever orders. And today we might be able to get enough polish to get code coverage working. I did install IDA in a VM, so I will be able to potentially get mesos generated so we can get code coverage through mesos. So, first I need to find the spy++ again. I forget where that was located. I need to actually make a bookmark of that. So let's say spy. Let me make sure that I'm not searching for file contents. I am. So this should hopefully be faster now. There we go. That's much better. So I'm going to pin this to start, and hopefully that does show up. Nope. Yeah, apparently the start menu just... Oh, now it shows up. Okay. All right. So let's first see if Spy is able to tell us where all the buttons are. And if Spy can tell us where the buttons are, then we can figure out how Spy works and then kind of go from there. So I'm going to drag this just on the main calculator window itself, and we're just going to take a look into that. Here we see we have the calculator window. Inside of here we have a calc frame, and let's kind of hover over it. So So the calculator window has inside of it a calc frame, which we see. It then has a dialog here, this is the B4 dialog. We see that in the list. All of these have separate elements. So given that SPY is able to detect kind of all of these separate elements, we're definitely going to be able to do that ourselves. So we need to basically figure out how SPY works, and we're going to try and get this information out of, kind of out into our own tool. Because if we could, basically every single spot where SPY is highlighting like this box, those are interactable elements, potentially interactive elements. So let's see here if these all break out. Yeah, these are all the buttons. So all we have to do is figure out how to enumerate these sub-windows, and it's probably actually a really simple problem. So we're going to take a quick look at that. This literally might take like 30 minutes to write this code to enumerate where all of the actionable elements are. So if I'm not mistaken, someone actually sent me something yesterday that I think did this. It like looked for the sub-windows, but let's search Windows, API, MSDN, sub-window. So we've got find window, enum windows, maybe. So enumerates all top-level windows on the screen by passing the handle to each window. That might work. So this is going to give us a function that will, well, this is top-level windows. I want like the enum thread windows. Enumerates all non-child windows associated with the thread by passing the handle to each window. Enum child windows. Enumerates the child windows that belong to a specified parent window by passing the handle to each child window. In turn, the application-defined callback function continues until the last window is enumerated or the callback function returns false. I think this is probably what we want. Enum windows, I think, only does the like windows with title bars, and I'm guessing child windows probably are all of these sub-windows. And if that's the case, we might just immediately hop into it. Let me get some music up and running. Let's see if this works. All right. So, does that sound like a fun plan to everyone? We're going to hop into our project, which we put in Twitch under something. Yep. We're going to do cargo new bin, and we're going to call this GUI fuzz. Mainly because this application we're going to try to keep a little bit cleaner than the last one. And this one is going to be, this one might actually turn into a real tool that is actually useful for GUI fuzzing. So we're going to grab some of the defines from the old one. And we're going to immediately start off this project by making another file in source, and we're going to call this like winbindings.rs. And we're going to start moving kind of all of the Windows-specific bindings into this so that we can write a little bit better code. So in this case, we're going to just look at find window. Then we also need this string to UTF-16 function. And this window class, we don't want all of it, but we want a lot of it, so we're gonna grab it quickly, and then we'll start kind of deleting things we don't need. So we don't need any of the key press stuff. We can always copy that in when we get to that point, but we want to start kind of with a clean slate. All I really care about at this point is I want to be able to attach to a window. That's going to convert it. It's going to look for the window with that title. Interesting keys is now gone. Successfully got a handle. Return an error out. We're going to need to get IO error in these two. And then we'll want this down here in this main.rs. So this is a pretty common way for me to develop, where I just kind of splice in things from old projects I've written. While I don't use much third-party code when I do development, I do use a significant amount of reused pieces from my own projects. And then we'll pull in this module, pubmod winbindings, and then we'll use winbindings window. And we should be able to do let window is equal to window attach calculator. And I think that's everything out of this application that we want right now, so we're just going to close that window, and we're going to switch to kind of more of a development environment here. So we don't have cell. Actually, we don't have that anymore. Window is private. Yep, so now we just have to start marking these public, since we didn't previously have that. That's good, we can keep those all private. Alright, so now that's going to allow us to attach to a window. We can put a question mark in there, and now we've correctly handled that. If we don't have calculator, this should now hopefully fail to run, right? Do I have another calculator window open? Shouldn't. What's going on here? Somewhere I have a hidden calculator window, I guess. Oh, it's, I guess because I have spy on it. So if I do a refresh of that. Oh, it's because it suspends it. All right. So we've got that. Let's see if we can actually... We're going to pin this to start. And we have a better way of opening this. So now we can find that. Good. Everything's great. Hunky-dory. Oh, there's one other thing that we're also going to do today is we're going to figure out where the settings are for calculator because we can see that it opened up in programmer mode. So it remembered that we had it open in programmer mode before. I'm guessing it's some sort of a reg key. We're basically going to want to delete that registry key every time we start a calculator just to make sure that it starts in the same state every time and we delete all previous state. We're going to move to a fuzzer that's probably going to be a stream of commands. So we're going to have kind of a vector of like, do these mouse movements and these key presses. And if we start from a different state in a calculator, we won't be able to replay those events. So, let's see. I'm actually going to switch up the music. I'm not feeling this right now. I can put on... I can go back to the lo-fi hip-hop. I think that's nice and easy to listen to. All right. So now that we've attached this window, we're going to write another function to kind of enumerate the sub-windows. Pub-fn, enumerate sub-windows. And that's just going to take a self. We'll do an IL result. I don't think we're going to have to return anything from here yet. We will eventually, of course. And we're just going to do window.enumerate subwindows. Obviously, that doesn't do anything yet. We're going to put a question mark to capture that error. And that looks good. So we're going to take a look at this function. It looks like this is going to take a function callback, which is really annoying. I hate function callbacks. It means that we have to kind of pass some pointers around. They're just a really stupid concept. Well, in C and C++, they're a really bad concept because there's no safe way to do it. We've got that. We have a func. This is kind of like the callback routine. We don't know what that is yet. And then lparam. And this is a usize here, and this function will return a bool. So if we take a look at this procedure, we can do a type def of enum child proc. Oh, not type def. Type this is equal to, this is a function that takes in a wind. It takes in the lparam, and it returns a bool. So this is the callback, let's say callback, I don't know how to describe this, callback function for enum child windows. And then this, we will take that parameter instead, and we'll just space this by 80 columns, and we should be good. That looks good, and that's not child, safe there. We need to extern C mark that, and now we should be solid. Foreign function never used, alias is never used. Good. So we're going to have an internal function here, which is going to be enum child window callback. This is just going to be an implementation of this specific callback. So we're going to do wind lparam pool and callback. And I think if we look at the API here, this is going to handle to the parent window whose child windows are to be enumerated. We have a pointer to the application defined callback function, and then this return value. The return value is not used. Okay. If a child window has created child windows of its own, this enumerates those child windows as well. Oh, does that mean it recurses into... Really? If a child window has created child windows of its own, it enumerates those windows as well. So I guess this is recursive. I don't know how we're going to know what depth we are at then. That's... I guess I don't know if we really care what the depth is. I gotta ask what keyboard or switches are you using. So this is a DOS keyboard with Cherry MX Blues. This is kind of an old school mechanical keyboard. I mean, like obviously mechanical keyboards, an old school mechanical keyboard is 30 years old and this is only like 8 years old. But this was, DOS keyboards, if I remember correctly, were some of the first mechanical keyboards kind of in this new rising of mechanical keyboards. Because I mean, 10 years ago, no one had mechanical keyboards, and now pretty much everyone has them. So, yep, just a DOS keyboard. I can actually point my mic a little bit away from it to hopefully decrease some of the noise. I know it provides some cool noises in the background. All right, so this is just going to enumerate. It should do this callback, and I remember seeing somewhere... let's see, a child window that is moved or repositioned in the Z order during the enumeration process will be properly enumerated. The function does not enumerate a child window that is destroyed before being enumerated. Okay, cool. I kind of just assumed that. To continue enumeration, the callback function must return true. To stop enumeration, it must return false. Cool. So we now have this, and we just need to call this function with our own wind, self.wind, and then we're gonna do the callback function itself, and then a 0 for the parameter, and we're just gonna assert. Actually, we can say if not this, basically if it returns false, then we're gonna return an error here. In fact, we can just go this route. Cool, so we're gonna enumerate all the child windows for the window that we've attached to, return an error if there was an error, otherwise okay. And I'm gonna slightly change this to be a positive version where it's the okay is the first part of the branch. So this is child windows successfully enumerated and failure during call to enum child windows. And then this is, we're just gonna say, I know it's a pretty obvious comment, but I like to be a little bit extra verbose with my comments. I know people sometimes hate that, but I think comments should be as verbose as you can make them. So apparently this is failing enum child windows. It doesn't look like we ever saw our callback. Oh, that is, we failed to attach the calculator, so we don't have calc running. Boom. So we've got all the callbacks here. And if we look at this, we should have a wind here. So these are all of the handles to all these windows. If we were to bring up spy++, look for these windows again. Let's just boop. Yep, sync that. And we should see Yep, we've got the AOAO, we've got the DO, we've got the B9. It looks like it recurses into 505BE, 1C, blah, blah, blah. So we now have access to kind of all of these windows. I'm actually going to go through a little bit extra trouble to figure out what the hierarchy of these windows are. Not that it's really necessary. We do have access to all these window handles, and now we can figure out where they are and read the text on them. But having the hierarchy would be kind of interesting to know. So what's tough about this function is that it does recurse. And actually, I should be able to safely do this. So this is going to be as mute self as usize. So basically, we need to now take a mutable reference to ourself. Actually, do we even need that? Let's do a listing here. Let mute listing is equal to vec new. And then we're gonna do listing dot God, what is it called? Into raw, I think. And I think this is vec into raw as usize. Function associated. Okay, let's just take a look. Rust up doc. Vec. This. Raw. I might actually just throw this in a box to make it even easier. Otherwise, I need to track kind of all of the length components of this. So we're going to we'll actually just make another structure. Pub struct window listing. And then we'll, inside of here, we're just going to do, how do we want to do this? We're just going to do this for now. List of all window handles. And structure which contains a listing of all child windows. And let's see if, okay, so the first element of this is a child. So we don't actually see the parent in here. I think we will want to put the parent in this, but it's not a big deal yet. So we're gonna do a box new of a window listing defaults. We're gonna create a new default implementation for this. Actually, we don't even need to put that in a box. So we'll do listing, and then here we'll do mute listing as mute window listing as usize. And then here we will take let listing is equal to, and this is going to be a mutable reference of a window listing, and that's going to be created from lparam as mute window listing, and then we'll deref that. So this will deref that, which will turn it into a window listing, and then we'll make a reference out of it. So this is how you convert from like a pointer to that. And then here we can do listing dot push quind and continue the search. Get the parameter we passed in, and then this will be add this window handle to the listing. So this, I think, should be good, right? In theory. Method not found in window listing. Yep, because this is Windows here. Cool. And now down here, instead of returning OK, we're going to return a window listing. And then we're going to make this public. And we did. We're going to implement debug on this as well. And now we should be able to print all of the windows as hexadecimal that we got from the enumeration process. So we've now probably collected them into a vector, listing. Nice. we've now gotten all of the child handles for the window in this list. So this is going to enumerate all of the sub windows belonging to self recursively. Internal callback for enum child windows used from the member function. Okay, so create a new empty window listening. Nice. This code looks pretty clean so far. We haven't done anything too crazy. And then I think we're gonna name this, we're gonna change this from window. Actually, we're gonna make this a list of windows. And then we're gonna wrap these. We should just be able to do this. Can't be formatted with debug. We're gonna implement default and debug for this as well. Actually, we don't want debug, that would make no sense. Okay, so now these are all wrapped in window objects, which means that we can use the enumerate sub windows on all of these different things. So let's figure out where, okay, how do you push a button? Actually, let's see if we can get the name for it. So Windows create button. How to create a button. We want to do create window. We're gonna like mark the styles of it, and then that's the class, and then the button text. Let's take a look. I just want to get the text out of these things. In this case, it is it's just the name of the window. Okay. Get window title, if I'm not mistaken. Get window text, and we want to do get window text W, and we're gonna do function get window text W, quind usize, string mute. This is gonna be a mutable reference to U16s. That's gonna be null terminated. The buffer that will provide it. If the string is as long as or longer than the buffer, the string is. If the string is as long or longer than the buffer, the string is truncated and terminated with a null character. Okay, that's kind of a gross API, but whatever. I mean, it's standard. It's not like a big deal. But I don't like when I don't have a way of getting the length of it. Get window text length W. Retrieves the length in characters of the specified window's title bar text if the window has a title bar. If it's a control, it receives the length of the text within the control. Cannot retrieve the length of text of an edit control in another application. Why not? Why not? Okay. Maximum number of characters to copy to the buffer, including the null character. If it exceeds this limit, it is truncated. So we're gonna say this is apparently that's an int, even though it should be a usize. And this one returns an I32. God, so inconsistent. This is a usize here, and this is going to return the length in characters of it. If it has no text, the return value is 0. Okay. So then, using those two APIs, when someone asks how I learned Rust, I'm going to tell it because of Gamozo. You know, I really hate the whole, like, Rust, like, everyone's saying, like, you should use Rust, blah, 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 and forcing this. I have no loyalty to Rust. Like, I'm not going to preach about Rust and say it's better than any other language that will exist. But, it's just, it's the best language out there for systems dev. It just is. It objectively is. That doesn't mean that there can't be better replacements in the future, or that there can be modifications, or that there are shortcomings or issues with it, but it is by far the best language for systems dev. It just is, hands down. You could say Go is also really good language for native dev, but I would say native dev is a lot different from systems dev. I would say native dev is like stuff that compiles down to something about as fast as C. And I would say systems dev requires that you can basically design an operating system in it. You can make an operating system in Go, but you have to implement the whole runtime. And if you have to implement a runtime, I don't really consider it a systems language. The fact that Rust has no garbage collection is probably the most important aspect of it to me. I hate garbage collection. I recognize there's a place for it. It's great in a lot of certain situations. But for basically all of my uses, I almost never want a garbage collector. I want to know exactly what's going on. I like that when you run Rust Hello World, only one thread ever gets created, and that's like the main thread. In Go, you're going to have like a bunch of threads. You're going to have workers and things like working on garbage collection. I know that there are ways to turn that stuff off and work around it, but I would rather have a language that works with me than one that I have to work around. But that is my own personal opinion for my uses of a language, which are much different than the average person's development environment. So that is not what I'm trying to say. So here we're now going to say we're going to do let text len is equal to this. And we're going to do self.wind. That will get the Windows text length. If it exceeds its length in characters of the text, it might be greater than the length of the text. For more information, see the remarks. Blah, blah, blah. May return a value that is larger than the actual length. That's not a big deal. I don't really care. So all that matters is we're going to do this. We're going to say, and this function, we're going to ultimately return a string. So now we're going to allocate a new object. I don't think that can go negative, but we're just going to assert that text len is greater than or equal to 0. Unexpected result from... because I don't see what the error case is here, so I'm just going to say, we're just going to make sure it's greater than 0, and if it is, then we're just going to go with it. And then we're going to say, if text len is equal to 0, return OK string new. Basically, return an empty string if the window text length was reported as 0. Okay, and now we're going to make a new buffer. This is going to be the character buffer. We're going to call this the wide character buffer to be more verbose. This is going to be a vector of U16s because this is a character count, not a byte count. And we're going to do vec with capacity of text len. So allocate a buffer to hold text len wide characters. And we're going to go even further, and we're going to do checked add one dot unwrap, and text len here we're gonna do let text len is equal to text len as dot try into dot unwrap. We're basically gonna upconvert it to a usize. Use standard try into I think is what it is. Not quite. Um, 94, oops. Pub fn, yeah. Pub fn, window text, with capacity, whoops. Capacity. And basically we're going to convert the text length, which is an I32. We're going to convert it into a usize using try into, so that will panic if for some reason we can't do the conversion. We're then going to get the capacity, or we're going to make a new vector that has enough storage for text length plus 1, the null terminator. And we're going to do a checked add here. It's really pedantic. There's no reason to really do that. Like, the odds that you're going to overflow here are so low. But why not? Like, it's so easy to do checked adds in Rust, so we're just going to do it. What fuzzer are we using today? Yeah, we're making a new one. And yes, I did not set the font size up higher today. I think we found out that 18 was kind of the magic number for font size, was it? That doesn't seem right. 16? I think 16 is what we were doing yesterday. That's about as big as we're going to get while maintaining a relatively usable dev environment here. Trying to, yeah, standard convert. And then 95. Result here. Wow, we made a lot of typos today. Tring new. I'm just doing this to make sure it builds and everything. Call to an unsafe function, which is here. Unsafe. Wrap that up in a nice little object. Great. So we've basically created room. We've created a buffer to hold all of the characters. Although I guess we don't know that this is exactly the length that we need, because this is going to give the length in characters, but characters could potentially be greater than 16 bits. I don't know. UTF-16 is an extremely dangerous thing. And since this gives me the length in characters, what happens if there's a 3-byte UTF-16 character? Will this correctly give me another character, or will it... I mean, luckily, this function is also protected, this get window text, so this will also take the length that we created. So this is going to be the let's alclen. This is going to be the allocation length. And we're going to want to pick... this is the value that we're creating here. And I'm just going to double check quickly that this correctly is going to give me a pointer value, which it should, esource main, and we're just going to do window text. You know, it's pretty crazy. I haven't touched GUI programming since I was probably like 13, and I remember I did not even remotely understand how this stuff worked when I was a kid, but now it makes a lot more sense. Pretty crazy how that happens. So in win bindings, we're gonna now go up and we're gonna call the get window text length function. This is going to take, we're gonna call it get window text. Come on. Self.wind. We're gonna pass in the buffer, which is wchar buffer.asmute pointer. And then we're gonna pass in the characters, allocation length dot try into dot unwrap. That's going to convert it back into the I32 that this function expects, and then let ret is equal to this, and if it succeeds, it's the return value is the length in characters of the copy string, not including the null terminating character. So that is exactly what we want. We're going to do so we have to do another unsafe, let ret is equal to this, and then we're going to do wchar buffer dot setlen, which is an unsafe routine, is equal to ret dot try into dot unwrap, and we're going to see, can it fail? If the title bar is empty or the window control is invalid, the return value is 0. That should be fine. And we no longer need this to be a statement. So this is going to get the window text into this buffer. So get the window text. So at this point in Rust, basically with capacity means I'm creating a vector that can hold this many elements. However, the length is not modified by this. I'm passing the pointer to kind of the backing that was created here. But then here, I have to actually set the length of the vector. And this is an unsafe routine because it's just basically setting the valid length of that buffer internally to, and we actually don't need this because we, that assertion will fail here on that conversion. So set the length of the vector. So yeah, basically we basically call malloc for this many elements. We then fill in that buffer behind the scenes. But at this point, if we were to print the length of the buffer, it would be 0. So now we update the length. We basically say that this many elements have been filled in. And at this point, we should now be able to look at the contents of the buffer. And this should have the title, the contents of that. So in this case, we have all of those. That looks good. And now, since that doesn't include the null terminator, we're going to do our conversion of UTF-16. I think there's a from UTF-16 on string. So we're just going to do a string from UTF-16 and buffer.asSlice. I think since that's wrapped in a result, expected an error, found a UTF-16 error. So basically we need to do a map error to convert the error, and we're going to do x.into, and hopefully we have an into on that. Looks like we don't. So we don't have a way to convert this from UTF-16 error cleanly into an IO error. So what we could do is potentially box that up. We could make this function instead return a result of this error, which is a trait, and almost everything implements this trait. Whoops. So this will now need to be a box of a dynamically dispatched. This is going to make like a dynamic allocation of something that implements the error trait. And, well, that's going to be a namespace issue. Do we use error? We do. We're going to do this. We're going to drop the IO error in favor of the other one. Okay. So now we're going to start having some issues. Where's this at? 8. Cannot convert the error to that. We're going to have to kind of convert all of these to boxed errors. So this is going to be standard error. And this will now be a result that the box done. Basically, this allows any error that implements the error trait to be used as an error. I don't know if we need this into anymore. I think we can just do this. We do need the into still, but that should be good. Okay. So now we'll print the window text here. And we're doing that on calculator, and we get calculator back. That looks good. So now what I'm going to do is I'm going to implement display. So let me add a comment here. Convert the UTF-16 string into a Rust UTF-8 string. So that should be good. Okay. So now what I'm going to do is I'm actually going to implement manually. I'm going to implement display for window. So basically, this will change what you get when you do a print of this and when we have a window object here. So this will allow us to make like a custom formatter for when we display a window. We could also implement debug manually. I'm actually going to do debug. I like implementing debug a little bit more in this case, mainly because it's going to be a little verbose. So we're going to look at what the correct style is here. Looks like this. And here we're going to do format debug, use standard format. That should be good, and obviously that's not going to work, but I think this is the right ballpark, so we can print window wind x. So this is basically what was auto-implemented for us in Rust. Expected blah and format string. Yeah, you need to double escape those. So now we basically created our own custom formatting for debug. So what we're going to do next is then we're going to add a title. And this title is we'll put this in quotes. And for this, we'll do self dot window text. Gets the title for the window, or in the case of a control field, gets the text on the object. I think that's relatively clear. Window text this. And that cannot be formatted. We're just going to do an unwrap here. Okay, so now we see the window handles, and then we see all of the titles. So here we see the hex and the decimal and the oct and the bin, the quad word, D word, word byte. That's interesting. I don't know why we don't see like mod or rotate right, rotate left. There might be another field that we need to do. So let's take a look. So if we take a look here, we should see this dialog. We have the hex spin, blah, blah, blah. We can kind of see these in order. And it looks like these are buttons here. So let's see if I can, what sort of information is here. Styles, windows, class, button. Interesting. I'm kind of curious where this is. Window procedure. Do all of these have their own window procedures? This is at 6630. This one's at 6630. Okay, so they use the same procedure. I'm gonna try and find. We're gonna search for an actual button. Let's just look at the CE button. Yeah, that's weird that it doesn't have a caption. I don't know where those letters are coming from. Let's look at 8. So this is the button that implements 8. I just want to look at messages for this. Interesting. So now we see this, and when we click it, we do correctly see, we see a set cursor, left mouse button down. Okay, so now we're basically seeing all events just specifically for the 8 button, which is really cool. Honestly, this Windows like UI design is actually pretty fantastic. That these are all like windows and you only get events for like the specific objects. I mean, it goes to show why Windows got such the adoption that it did. Can I try and run it on MS Paint? Sure. Let's we can just do that quick right now. Why not? Paint to see how much it generalizes. And yeah, that's the goal. We're gonna try and make an extremely generic UI fuzzer. It's just gonna be aware of kind of where all the elements are on the UI. And here we go. We've got the ribbons and all of these buttons. It's interesting. I actually don't know where these must come from then, because this is not. I bet the ribbon stuff uses like a completely custom thing that's built on top of these. So, because I know this enumerates recursively. So that's not as nice as I wanted, which is a little annoying. But let's see if it works on Modern Calculator on like this Electron application. Yeah, like this doesn't even have any windows. Like I bet this is, if we look at Spy, I bet this isn't even using any. Yeah. Application frame input sync window. So they probably handle all the events for everything and then manually render buttons. Like literally Electron has completely thrown old Windows development in the trash. It's replaced it with something that's fundamentally worse in almost every way. There's no standardization between applications anymore. The OS no longer controls like the rendering and display of windows. It's really a shame, to be honest. It really is a shame. So here's this. I guess we don't. I don't know how to get the button text on these, and it doesn't look like this is being friendly to us. So the caption on here is kind of blank for all these fields. Obviously, these have captions, but these don't. So window procedure, window handle, client rectangle. So we're going to want all of this information, which will tell us like where to click. Yeah, but I don't see anything in here that gives us an 8, which means there's probably an API that we can use that, let's do Windows API dev set button text. XAML UWP. Yeah, I guess it's not technically Electron, but it feels very much so Electron-y. But yes, it's not technically Electron. I don't know. I think the whole UWP push is just an unnecessary change and basically 10x's all of the performance overheads of every user interaction you have. It's I don't know. It's really frustrating. Change the button text and size. Create font. Get dialog. Set font. Okay. Change the background color. Set window text. So this clearly is not working. How do you get the... It definitely makes you able to write applications faster with like UWP. And that's the direction we've decided to head as society. We've decided that we no longer care about performance. We no longer care about usability. We no longer care about documentation. We no longer care about functionality. We no longer care about good UI design and testing. All we care about is how quickly can you make an application so you can spin it and make money. And look at what we got. I mean, look how terrible the new start menu is. It just... It's a shame. We threw out 30 years of optimization, development, and testing and research and replaced it with something radically inferior. I don't get it. It's really frustrating to me. Obviously, that probably shows up in my statements. Okay, so I gotta do a little bit more searching. So get button text from Wind. Hey, Live Overflow, how are you doing today? Glad to see you sticking around. Get dialog item text, maybe? Wow! I'm trying to retrieve the text of a button in calc.exe. Maybe this guy wrote the fuzzer and found all the bugs before we did. The button, just a normal window, blah blah blah. That is the control ID. No text is returned, though I am able to click it programmatically. What am I doing wrong? Get text still doesn't work. Okay. You could simply use accessibility. Oh no. Oh no. Oh geez. Do you have to hook these things? Well, I guess we're just not gonna care about what the text is on the buttons, and we're just gonna start clicking buttons, I guess. Wow, that's a thing, I guess. Okay, so we're gonna... I guess that is not an easy process, so we're just gonna ignore what the button is, and we're just gonna click random buttons. And then let's also see if we get like these fields. I think we do have all of these. So we're gonna spy on this. Good. We're gonna sync that, and then we're gonna take a look at the messages. And it looks like left button down, L button, and then the position. And it looks like the position is relative to the button. So I think we're just gonna be able to do a post message now specific to these things. I'm sorry, Live Overflow. I hope you had a good evening now. Yeah, it's so weird. I don't see I don't see any strings returning that, so... But yeah, it looks like we're going to send a WM left button down. I'm looking at 1226. This one. And cool. So this is exactly what gets sent to it when we click it. So now we're going to open up the old project that we started yesterday, just so we can grab the input passing stuff. And I think we just want post message today. We're going to switch over to post message because it's going to be cleaner, and then we won't have to worry about losing control of the window. Everything's going to be sent directly to the window now, which is just going to be a lot cleaner. We're going to rename this wind. You know what? I've started to restylize kind of all these things, so I'm just going to do that here. And now we should just be able to do a post message. And if we look at the message type, what did we see? We saw an L button down. And then eventually we'll see an L button up. And these keys, we have the positions, the X and Y. So this is going to be the X and Y coordinates here. Okay, so WM L button down. And this is going to be we're going to make another, I don't know, I need to think through my coding conventions of should I use enums or should I think for these I want an enum. For these we're going to do a ripper C enum message type. We're going to do an L button down. Oh, it's 0201. Left mouse button down event. Different message types to be sent to post message and send message. So then we're going to do click. We're going to call this left click. Does a left click of the current window. And remember, we're operating on all of these window handles of like all the buttons and everything. So we're going to be able to do a left click directly on this window. This will be on safe code. We're going to do a post message W to self.wind. We're going to do a there's wind bindings. Message type L button down as, what did these take? Is this a U32? Yes. So we're going to refer this as a U32, as a U32. Then the L param, in this case it was just a 1, indicates whether various virtual keys are down. L button, M button. So left click, and we're going to make another structure. This is going to be called mouse states. This is going to be actually event state. I don't know. Key mouse state. I don't have a good name for this. Holds the state of some of these special keyboard and mouse buttons during certain mouse events. And then this will have control. Control key is actively held. This is left mouse button is down. Left mouse spool. And then we're going to basically construct this from these things. So we've got right mouse, we'll have middle mouse as well. Middle mouse, right mouse button is down. We've got shift key. It's down. It's down. Shift. First X button is down. This is going to be X button 1, X button 2. Second X button is down. Then we're going to implement this. So we're going to be able to convert this structure into the raw impl from this for U32. So we're going to be able to convert from the key mouse state to U32 from self U32. And then here, we're just going to do self dot left mouse as U16, actually as U32. I think these are actually U sizes in this case because they're L params. So we're going to do this. This will basically be a 1 or a 0, depending on whether it's set. And then it looks like that is in the 0th position. Actually, we're just going to do this because it's going to be a little cleaner. If left mouse, then 1, else 0, or, and we're just going to do this for all the buttons. Middle mouse, right mouse. And by programmatically kind of designing it in this way, we're actually going to be able to get control over kind of mutating and generating these different states. So left, middle, right, shift, X, 1, 2, control. And now we're going to align this because otherwise I'm going to freak out. So we've got left button, middle button is 10, the right button is 2, shift is 4, X button is 20, X button 2 is 40, control is 8. So if those are set, we set those fields, otherwise those. So now we can create kind of this X button thing. Love the extra air on wind. Wind. I don't think I've ever vocalized it before, but it seems to make sense. I don't know. It sounds good in my head. It's an easy way to say it, right? I'm not making it harder, am I? So now we're just gonna say state is equal to default of this. Actually, we can use this syntax. So we're gonna say that the left mouse is gonna be set to true, and then everything else will be set to the default states, which will be false. And then we should be able to print state here. We're gonna do this before we do post message, and then we just need to invoke this routine. So we're gonna do this window.left click. Oh boy. Usize is wait. Did I do this the wrong way? Implement from that for usize. Oh, this is going to be implementing on usize itself. I guess we could do into usize. Technically, you should implement the other way. You should implement from, but what are we doing here? Into what do you mean expected identifier? What? Did I forget how to implement into and from? Oops. So you should implement from. We could go the other way, which is the correct way, but we can also implement into usize from for QMO state. We got this, just takes a self. Expected identifier, found keyword. Am I going crazy? Did we like not close a parenthesis somewhere? Say GIF. GIF. Expected use size because of return type found closure. I am going crazy. I am going crazy. What? What? What is going on? Expected, one of the... Like, the parser is in a really weird state. Let's just comment this out. Let's quickly see, like, what happens. Left click is private. That's fine. We'll make it public now. Impl this for key mouse state. Function self usize. If self dot. What? I'm just doing this temporarily. That works. Is it, do I need parens? Consider adding a semicolon. Am I getting crazy? Am I doing something? It's just parens. I didn't know that was required. Oops, I got that one, the last one backwards. All right, so true, false, and then if I print state dot into usize unexpected type argument. Yeah. Whatever. Okay. Now we can do state.into, and we could actually make this take a state, potentially. State option key mouse state. And then the reason we're going to make it an option is it'll make it cleaner to use when we don't want to actually use any of these fields. So we're going to do key mouse state. And we're going to make that a let state is equal to state.unwrap or default. So basically it's going to get the state from the state field. Otherwise it's going to create a new state where everything is set to false. So create a get the state or creates a new empty state. So now at this point, we'll have state from inside of this option. Otherwise, we'll have an empty state. And then here, we're going to do state dot left mouse equals true. And then the coordinates, we don't care at all about the coordinates. And then post message, I think, what did that return? It returned a 1 or 0 or a 5 or a 10. If it succeeds, it's non-zero. So we're going to say... this will return an IO. Actually, we started to move to this pattern. Box dyn error. And then we'll do if dot is error. Actually, in this case, we can do an IO error because that's the type that we're going to be using, and that saves us a line of code. If this is equal to 0, I think that's just a bool, so we can actually change our implementation here. Post message, this is going to return a bool. If post message succeeds, I'm going to tab that in one more. We're going to do OK. else, we're gonna grab this thing. Post message W failed. All good. Sent the message. Actually, in this case, we want a not and an early return because we have to also lift the button up. So first, we're gonna set the left mouse to true. We're gonna do an L button down. We're gonna send that over, and then we're going to set the left mouse to false. We're gonna send a left button up, and then we're gonna return an error in that case, and then this will fall through, and we succeeded. Expected a type argument. Semi. Expected a what? What? Oh, IO result, not IO error. And then left button up, we just need that one. I think that's a 202. Left mouse button up event. We're just gonna double check that quick. L button down. L button up. L button up, 202, yep. And then 9, left click takes one parameter. If we pass it none, it's just gonna do a standard unmodified left click. And we can also add that. So that's gonna do a left click on the main window frame. So now we can go through for window in window.enumerate sub windows. We can try to left click them, see what happens. Oops. Method not found. I'm gonna implement iterator on window listing. Actually, I'm gonna implement deref. I always forget what this is. I think we need a type as well. So deref will basically change what will happen when you do like a deref of that. So it'll allow us to kind of wrap it into the internal object. Yep, target type target is equal to T. This returns a self target. I don't think it has to be a reference. Oh yeah, it does. This is just gonna be self target. And that's going to be, instead of a T, that's going to be a it's going to be this. And then we're going to do self dot windows. And we'll need standard ops deref. I think that'll do it for us. I don't know if I want the ampersand in the type or not. Left click, not found on window listing. Not error. Maybe I will implement iterator for it. Deref. If I do... yep. That can't be derefed. Not an iterator. That'll work. There we go. Sweet. So this now will press every single like actionable button on the GUI. So if we make this a little bit slower, we can do standard thread sleep ms. Let's just do 100, and then hopefully we can kind of see it like sweep through all of these different things. Yep. We have it sweeping through. Looks pretty neat. All right. So now we're able to kind of randomly send all these mouse events. So here I'm going to do a let windows equal to this. I'm going to call it sub windows equal to this. loop. Then we're gonna do let window is equal to, we're gonna need that random number generator again. I'm gonna make a new structure. We're gonna do pub mod RNG sp source rng.rs. Got this. Pub fn rng. Oops. Struct rng seed cell usize. Actually u64. Use standard cell random number generator implementation using Zorshift 64 internal Zorshift seed impl rng pub fn new that returns a self rand seed colon this here rng seed is equal to cell that, and then let mute ret is equal to this, let ret is equal to that for this. So we're grabbing just the tick count as the seed, and then we're gonna do ret.rand. That's gonna cause the seed to get kind of shuffled in there. Basically, this is like not a high entropy thing. This will generate 1,000 random numbers to make it a higher entropy thing. Create a new TSC seeded random number generator. Okay. And hopefully that does the trick. Looks like that should be good. Methods are never used, of course, because this is not public. So now we've done that. And we can make let RNG is RNG new. Create a new random number generator. Attach to the calculator window. Enumerate all GUI elements of calculator. Then here we're gonna pick a random window and sub windows rng.rand mod sub windows.len. Then we're gonna do left click on that and asleep. So pick a random GUI element to click on the GUI element, sleep for a bit. The from MS is deprecated, so we're just gonna switch to this. And unused RNG, use RNG. Rand is private. Problem solved. Sub windows, can't move out of that, of course. We want to do a borrow. Cool. And now we have no warnings or errors. So this is basically finding a random GUI element, and it's just clicking it. And it's doing one every, in this case, it's doing one every 100 millis. We can get rid of the sleep and just see what happens. So there we go. And now I can actually use my computer while this runs. Not enough quota is available to process this command. I see. I think we ran out of kind of cycles. Or it probably ran out of like buffering. It probably can only do a couple of these. So let's just sleep for 1 milli. And I'm gonna start moving to a release build. So there we go. So we're doing like one random key press, or or one GUI element action. Yeah, and it does look like even at 1 milli, we're still running into issues, but we can solve that. You can see it's like still actively handling these events, but this looks pretty solid. And there any reason you aren't using the rant crate? I just don't like dependencies. I will pretty much I'll go pretty heavily out of my way to avoid dependencies in many situations. That's just how I am. It's not necessarily right or wrong. I will say that it has resulted in me kind of learning a lot about how computers work by kind of doing everything myself. Code has modulo bias. It's actually a really unbiased random number generator. I mean, it's not crypto secure or anything, but it's a very good RNG. It's like one of the best pseudo random RNGs that you can get, even though it's that simple. It's actually pretty crazy. I've done a lot of analysis on it. People have done a lot of analysis on it. You can find all you want on it. 13, 17, 43. You'll find like papers all over the place on come on. There's a bunch of different things kind of going through like the quality of these RNGs, and they're actually really impressive. So simple, extremely fast, and the RNG that I'm using right now has a period of 2 to the 64 minus 1, so it doesn't repeat itself. It's like pretty crazy. It's actually a really good RNG, really simple. Nevertheless, we don't need high quality random for this. So now let's try it on a different mode. This looks pretty good. This looks a lot better. Like, the complexity of the things we're creating are much higher than what we had yesterday. This is really cool. So we might want to bias it to type some numbers or something. But this is looking a lot better than the fuzzer we had yesterday. So the only issue is this is not switching between the different window modes. And I think we're just going to manually implement those mode changes ourselves. So, looks like calc is not happy right now. I'm not too surprised. Yeah. Let's actually get that in a debugger. I don't know if there are going to be any command bugs with calc in terms of actually just entering different key sequences in there. I think the mode changes are where all of the bugs are. System 32, Win32 calc. This debugging, we've got page heap enabled. Everything looks good. We're going to set this to 10 millis. Maybe that will allow us to not hit the buffer limit. I mean, quite frankly, we can just do this. And now it will just ignore errors from the left clicks. So, sadly, we can't really see what it's doing right now because I can't foreground this anymore because it's just so busy handling all these events. But it's definitely switching modes pretty consistently. Honestly, I'm actually really happy with this. This is producing some pretty cool things. I wish I could get that in the foreground. Yeah, I'll restart it and I'll keep it in the foreground this time. Uh-oh, Windows is not happy. Oh boy. Sorry about that. I probably lost you for a second. Windows was not happy about what we just did. I'm gonna take this to 100 millis, and then we're gonna care about the errors again here, just to make sure we don't end up spamming. Probably dropped a couple probably dropped like 10 seconds of frames there. Sorry about that. So I guess the OS is still kind of getting hung up on things there. So Windows, System 32, Win32 Calc, open, run. We're gonna keep that there now in the foreground. We now have 100 millis between inputs. Okay, so we are seeing it using the memory mode. Actually, if I control C, so it looks like it can respond to 100 millis. 10 millis is too fast. 100 millis does look doable. We're gonna turn on history, digit grouping, maybe like one of these bad boys. Maybe not. We'll go back into basic mode. I just want to see it interact with some of the history fields. So I think it should be able to go in there and modify those. I actually might need key presses for those. So we might put random key presses to certain buttons and events as well. I don't think I've ever seen that dialogue. Ever. Has anyone ever seen that dialogue before? That's kind of cool. Nah, continue. Yeah, do the hard math. I mean, I think Calc is going to be unhappy. If we take a look at where it is, it's probably pretty deep in some math. Yeah, it's doing some like big int scicalc functions. So this would be fun to fuzz. If basically right now we're fuzzing like calc as an application, what we could eventually do, and it will probably be like maybe a couple streams down the road once we get like a really good GUI fuzzer and all of that working, we could eventually take the actual routines in Calculator and we could figure out how to like build this calc engine object ourselves, and then we could start like trying to create commands and expressions and fuzz more of the calculation side of things. And if we could find some expression that would cause a crash or recursion, we could then probably input it into Calculator once we know what that expression is. So that's probably where this will eventually head, and I'm pretty excited for that. But yeah, so we're gonna pull this back up, get this running. I'm gonna take the, I think we can just get rid of the delay, quite frankly. I think we can just buffer up as many events as Windows allows us to, and then we'll safely let this fail when there are not enough things to queue up. Yeah, because this is just going to process as fast as possible. And this looks gorgeous. Like, we probably just queued up like 10,000 different events for it to do, and it's just going through and doing it. We're hitting a lot of these exceptions. We've got a pretty good stack here of like a bunch of operations. It does look like we're hitting almost all the buttons. Wow. Windows lets us buffer a lot. This is pretty cool. I think this is more visually appealing than the last one that we did. That's pretty nifty. We're making some good progress. This is turning into a nice looking fuzzer. So it looks like it handled all the messages. We can requeue them up. Man, this is cool. And you can like visibly see like all the buttons getting pressed. I like this. Is this coverage guided with mesos? Nope, it's still just random inputs. We're gonna go the coverage guided direction probably in about an hour. So we're gonna get some key presses up and running. We're actually gonna hard code some of the special mode switch operations that Calculator allows. And then we're gonna start kind of working in that direction. So once effectively what we're probably going to do is, instead of sending random events, we're going to generate a stream of random events to send to Calc. basically like a vector, and we'll make like an enum that will basically describe all of the interactions that we're making with the calculator application. And then once we have a stream of inputs, we can then start doing code coverage, and we could start doing feedback on it by saying this stream caused this new coverage, and we could start splicing some of these unique events, and we could really start trying to stress code coverage. So I think we're actually going to be able to make a pretty damn good fuzzer out of this. So I don't think we're going to find any bugs with this. I mean, maybe overnight or something, or maybe if we scaled this out, we would. But we're going to switch away. We're going to restart the calc, and we're going to start manually looking through all of the things that we can do. And we're going to just start this in a little comment section. So we can go into standard calc mode, which is an Alt +1. We have scientific mode, which is an Alt +2. Programmer mode, Alt +3. Statistics mode, there's an Alt +4. Toggle history, Alt +H, which is technically only valid in standard scientific. Only in standard and scientific modes. Then we have a digit grouping, which we can't reach. So we could find Alt V I. So that's going to be digit grouping is an Alt +V +I. Basic mode, that's going to be a Control +F4. Unit conversion is going to be a Control +U. Then date calculation, Control +E. Okay, and then we have worksheets, which is going to be Alt V W M, Alt V W M, Alt V +W +M. This is going to be mortgage calc. We got vehicle lease, that's Alt V W V. Vehicle calc. Then we have VWF for fuel economy and MPG. And then VWU. VWU. That's the fuel economy in liter per 100. So VWM, VWV, VWF, Alt VWU. Okay, then copy, obviously simple. Control +C, paste. Control +V. I actually have been thinking about, like, if we were to find some use after free or double free or something, how would we groom it? I think copy and pasting might work. If we like copy a bunch of A's from Notepad, like 1,000 A's, and paste it into calc, while it might not actually put the A's into the calculator because they're not valid characters, I bet calculator internally like allocates enough room for the clipboard space and copies it in. So we might be able to get some crazy grooms in if we do get to a point where we might end up doing exploitation. Hey, Lost in the Woods. I did not know you. I found your YouTube a while back. Didn't know you streamed. That's super cool. Yeah, I do. I used to stream on Twitch. I got banned, so I switched to YouTube temporarily. But the YouTube kind of user interaction is just not as good. It just really isn't. So I'm kind of back to Twitch. Alt-DA. Alt-DA is copy dataset. Alt plus D plus A, copy dataset. Alt-DA, and that doesn't look valid unless we have history open. Okay, so not valid unless there is active history. So this is a pretty common thing for me to do when I'm fuzzing or reversing something, is I kind of make these notes. History edit. That's going to be an F2. So let's see. Alt-D. Actually, that's Alt-E. Alt-E. H. I. Wow, how did I get that so wrong? Alt-E-H-I. Alt-E-H-I. Alt-E-H. So we have escape will cancel edit. Then we also have clear, which is control clear. That's going to be control plus shift plus D. Control shift D, and then view help. F1 about calc. Alt H A. All right. Alt 1, 2, 3, 4. Alt H. Oh, that's Control H. See, this is why we double check our work. Control H will toggle history. Alt VI. That should have changed our digit grouping. Good. Control F4. Goes back into basic mode. Control U. Unit conversion. Control E. Date conversion. Alt VWM. That is mortgage. Alt VWV. Periodic payment. That's vehicle calculation. Alt VWF. Fuel economy. VWU. Fuel economy liters per 100. Then we should have Control C, Control V, of course. Alt E H. Wait, Alt E D. Did that change? Oh, history is not showing up. Okay, so history. EHI is copy data set. F2, escape, Control Shift D. If we're in some of these modes, date calculation, EH. Why do I feel like I've seen EH? Didn't we see like a different thing here? I'm going crazy. Data set. Okay, so in statistics mode, there's a dataset thing. Okay, so history is only available in standard and scientific. So this is history mode in standard and... Can you enter any characters in the fuel? Yeah. If we were to look at fuel economy, I went 100 miles. I used 5 gallons. I got 20 miles to the gallon. You can do distance, which goes the other way, and then fuel used, which is another conversion. That's actually kind of neat stuff. Tab that in. Actually, oh, I really messed that one up. So in standard and scientific mode, and then in stats mode, there's data set. So stats mode, there is data sets. And this is going to be EDA. So this is going to be EDA. We also have edit, F2, cancel edit, which is escape. And we also have clear, which is just a straight D. Okay, I think that has EHA. I think that is all of the possible combinations. Then obviously these things, there'll be like selections of these dialogues, and we'll eventually want to like type numbers and things in here. So I think we're gonna have like a 90% chance of typing a number, a decimal, or a minus key. So like, actually probably just a number and a decimal. So we'll have like a 90% chance of typing a number. We'll have like a 9% chance of clicking a random button on the screen. And then we'll have a 1% chance of doing like one of these mode changes. That sound good? That's kind of how we're going to start for a baseline. And we're going to kind of see where that goes. So I know we had issue with alt sequences before, so that could be a potential issue. So I'm going to see which window I can have focus. So it looks like I can kind of do it at any point. So we're going to need to add some key press stuff in here. And we're just going to hack this in to see if we can get the alt codes working. So I don't know where the right place to focus will be. Yeah. So if we take a look at... So that's the calc frame. Class button, blah, 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 blah. So I'm guessing that we can probably send the input to the main calculator frame, like the primary window. And we're actually going to call this primary windows this, primary window.enumerate. So we want to switch into standard calculation or standard calculator mode. So to do that, we're going to need to make key sequences. Sorry. So we need WM key down. And we had problems with this yesterday, but we're going to persist a little bit more and try and figure it out as to how we can do this. So we're going to do pub fn key down self, and we're going to kind of hack this in quick just to see if we can get this to work. Self wind, we're going to do message type key down x100 virtual key code. We're gonna do alt, so x12, and then what else do we need? So 12 0. I'm pretty sure this is what we tried exactly yesterday. Actually, repeat count, previous key state, when if it was down before the message was sent, 0 if it was up, always 0 for those. Indicates whether the key is an extended key, such as the right hand alt and control keys. Okay, they're not. Repeat count, we're fine. Then I'll send a key up, which will be a 101. And this will have 3 shift 30 set. So this is just gonna toggle alt. And basically, I want that to happen. I want like the view thing to get highlighted. So we're gonna see if that does the business. I think alt is a special key. Oops. I forgot we had I guess we apparently still had it fuzzing. My bad. Went through to calc. Oops. Went through calc.exe. And we're just going to switch back into here. We're going to do a return, okay, that, and we'll do primary window dot key down. I'm pretty sure this is exactly what we did yesterday, so I don't expect this to work. Did not. So Is there like a menu or something I can send it to? Let's see what the messages look like on the window. Oops. Calc this. So we're looking at the primary window. Synchronize. Oops. Messages on the primary. That's not right. Calc. Okay. Sync. Close. Messages. Where are the messages? What is going on? Window Finder. What if I look at this? I think Spy broke. What? What? Ooh, Spy is not happy. What is going on? It was working before. Spy's encountered a problem in the message hook. Okay. This, yeah. Good, okay. Sync, yeah, Messages. Why does that no longer work? And then, like, everything else freezes up. Something internally in my OS, like, something in my OS state is broken right now. Pretty bad. Let me make sure there's no Spy windows open. And then Win32 calc, we're gonna kill that. Oops. What is this? Messages. I don't know why this is broken. Please has encountered a problem in the message hook to prevent hanging the system. I've like broken something in the kernel. Like Spy is broken. I can no longer intercept those events somehow. Huh. Okay, so we're gonna try and do what's character? Ooh, maybe hotkey. Ooh, maybe app command. I think app command is probably what we want. It's a long TLS handshake. Notifies a window that user generated an application command event. For example, clicking the application command button using the mouse or typing an application command key on the keyboard. Handle to the window. Where this can be a child window of the window receiving the message. Okay. This can be, ooh, toggle the bass boost. Oh, decrease the bass. Oh, we're gonna make calculator turn up. we're gonna increase that bass so much in calc. Okay, copy paste, app one, undo redo, increase and decrease the treble. DW keys indicates whether various virtual keys are down and can be one or more of the following. Okay. So, turn down for calc. Posts with the keyboard focus when a doing Posted to the window with the keyboard focus when a WM keybound message is translated via the translate message. Character contains the character code of what key is pressed. Context code. 1 if the Alt is held down when it's pressed, otherwise 0. Okay. Maybe this will get us Alt sequences, maybe, question mark? We're gonna send a 102. We're gonna send an Alt 1. So we'll send a B1 as you said. Actually, we're gonna do a 3. This will try and switch it into programmer mode. Turn off history, turn off digit grouping, go into basic. So we want 3, and then repeat count, scan code, indicates whether it's extended, context code, 1 if the Alt is held down, otherwise 0. So we're gonna shift 129. So this is basically doing an Alt 3. Previous key state, 1 if it's down before the message was sent. Yeah, why not? And then the transition state, the value is 1 if it's being released, 0 if it's being pressed. So we'll set previous key state was, we're just gonna do this. Alt is held, we're gonna hit a 3, then we're going to release a 3 while Alt is still held. Right? Right? That typed 2 3s. So this should type a single 3. Okay. Huh. Sys key down. Posters to the window, blah, blah, blah. User presses F10 key or holds down the Alt key and presses another key. Okay. We'll try this one. Virtual key code, this, scan code, context code, 1 if it's held down. If it's 0, that's posted to the active window because no other window has keyboard focus. Previous key state, transition state, always 0 for sys key down. And then we have a sys key up. Oops. Sys key up, I'm gonna guess it's a 5. Previous key state, 1 if the key is down before it's sent, 0 if it's up. Then sys key up. We're gonna say 1 and 1 and 1. So I guess we want 1 shift 29, and then in this case we want 7 shift 29, which is the same as OB111 shift 29. So that will set this, this, and this. So man, this is a hard problem. Does F10? F10 brings up the menu. Let's see if we can just do a raw F10 then. So let's do a up down of F10, and then maybe we can navigate the menus with arrows. It's gonna be a little gross, but you know what? We're gonna take whatever we can get. So we're gonna do key down, which is a 100. We're gonna get a virtual key code for F10, 79. Then we're gonna do a key up. So key down, always that. We should have, this will be that shift 30. So we're gonna hit F10. That seemed to work. So, okay. F10 V. Let's see if we can now hit a V. V as U size. Maybe it's because it doesn't have focus. I don't think that's the case. Sys dead character. What's that? A dead key that is pressed while a system is holding. The character code generated by the dead key. A dead key that is pressed while holding down the Alt key. I don't know. Post message menu. How to click on menu items with post message. Pressing the menu item. Blah, blah, blah. After long research, he found the solution. You'll need to find the left button up, down, not set cursor. Change format that by adding K. Left button down, left button up. In case that worked. Okay. Maybe I can do. I bet I can do F10 down. Can I do a down arrow? I bet I can do that. Maybe. Down arrow, 28. So we're gonna hit F10, we're gonna hit down. No. Oh, whoa. So the first try it didn't work, but the second time it does. That makes me feel like maybe I need to sleep. Let's do 50 millis. Uh, 250 millis. We're gonna give it basically an eternity. No. What if I put some sleeps in here too? Yep. Yeah, sleeps all over the place. See what happens? That is bizarre. Why would it work if I do it again? F10 down. I guess maybe I can do F10 down. Nope. What about... I mean, this mimics basically running the application twice. So we'll do F10 down, F10 down. All right. So that works. F10 down, S. So, do I need double F10? No. F10 down, pops up the menu. F10 down does not. I need to do F10 down. I don't know why. I have no idea why. We're going with it. Fuck it. We'll do it live. Okay, so now I have a hunch that we can now hit a P, a capital P, and this will put us into programmer mode for the first time programmatically. Woo! I have no idea why that works, but who cares? Who fucking cares? Wow. What on earth? All right, so that means we can now probably navigate all the menus. What if I do F10V? F10V, that works normally. I think we did try F10V, but we didn't try the double F10V, which is the real play. So we're gonna do F10V first. No dice. We're gonna try F10VV. No dice. We're gonna try F10 V F10 V. No. I don't know what miracle the double down is, but it works. So wait, what? Oh, maybe we just weren't seeing it. Oh, you know what? Yeah, that would just have left open the menu. I don't know what it is. The double down is magical. Like, look at that. Okay, so F10 right down. So let's see if we can find the right key. 27. Let's see if we can get that edit menu open. No. Let's do F10 right, followed by a down. All right. So can I do F10 right? F10 right to open up the help menu? Whatever it is, just do it twice. Whatever it is, just do it twice. Okay, so we now have access to the menus. It's scuffed. It's a little bit scuffed. But you know what? We're gonna go with it. We're gonna make pub fn open menu self. Okay. And then we're gonna make a new enum. Different types of virtual key codes. Enum virtual key code. So we need F10. This is some magical stuff. Down. This is going to be equal to OX28. Left 25. Up 26. Right 27. Hey, but we're doing this without having to send system-wide keyboard actions, which is fantastic because it means we won't lose usability of the computer. Mostly. OX79. Kind of weird to have that F there. We're gonna call this Func10. We'll call it F10. The compiler's probably gonna complain at us. I don't even know if we're supposed to be able to do this. Like, this might not be intended behavior, but I don't really care. 26, 20, 25, 26, 27, 28, 79. So now we're going to implement something called open menu. And then the menu selection opens a menu from the menu bar based on a left to right 0 indexed number. So we're going to start off with an F10. We're actually going to add these codes as well. This is WM key down. We could maybe do hotkey. Hotkey might allow us to skip character. Translated by that, character contains the character code of the key that was pressed. Repeat count, scan code, one of the alt key. I think character might just allow us to like press a button so we don't have to like send 2 messages. The fewer messages we can send, the better. So we're gonna just try it. If it doesn't work, we'll just revert. Character is equal to OX 0102. Presses, sends a key press event to the window. So we'll do message type character down here. is usize. Then we'll send virtual key code, right? Got a lot of splits going on right now. I'll kind of minimize that one temporarily. Message type, virtual key code, colon F10 as, I think these are usizes, yeah. So we're gonna send an F10, and I don't think we have to send any codes. I think we can just do that. So we're gonna send an F10 down, F10 down. Doop, 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 doop. And then up here, we're gonna do an open menu on 0 for now. Obviously, it's not using that index yet. Message type, expected to U32. Yep. Yes. Okay, and well, that didn't work. It made 2 parens. Okay, so I guess we're doing the key up, key down. Key down, event to the window, key down was 100, and key up was 101. Key up, character. So here we'll do pub fn press key self key usize IO results presses key down and releases it. Does it have to deal with some race condition with window focus? I'm not sure because we're never actually getting focus in the window. So I think something like that could be pretty likely in this case. So we're gonna take unsafe key down. Gonna press the key. I think we wanted 129, I think. Key down, 29. We want 0 for that. So we'll send a key down event with 0, 1 if it was down before, wasn't, so then we'll do a key up, a 101, and we just want 3 shift 30 for this, for the last parameter. And then I think if not this, return post message failed. We'll do the same thing down here. If not post message failed. Have to indent that in, put a little curly brace in there, and then, okay. Technically we can, yeah, we'll do this. Press the key down and releases it. Then we're gonna do, we're gonna press down F10. F10 down, F10 down. So this should hopefully do the trick. Let's get this result in here. Open menu 0. Expected results, yep. Why is that not working? 'Cause we didn't do a key up. Working on the calculator that we know and love. Yep. What? Key down. F10. Key up. Key. 3 shift 30. Key up. Key up. Always 1. F10 down, F10 down, right? Isn't that the magic? Okay, yeah. Okay, and then in programmer mode. Wait, does it not work in programmer mode? Oh! Why? Why would it not work in programmer mode? I don't get it. Let's just try a new calc instance. Because F10 down does work. Well, that's so it works there. Works there. Works there. But God forbid you do it in programmer mode. Really? Try B3 as usize. So this will shift us into programmer mode. Oops, we want P here. Boop. Okay. That works. That works. But if we're in programmer mode, let's see if we can get into stats mode. V. Let's try A. That will put us in stats mode. So let's double check that this goes into stats mode. It does. Programmer. Do it 3 times. If we could do it 3 times, then we'd be able to just do it by repeating it. Man, I can't even get that menu to pop up, can I? And I don't think the menu is like a spyable thing. I don't think I can do mouse events for these, I don't think. I mean, I could if I knew the right location of them. But and the message stuff is not working. Why would it not? Let's see, post message, menu navigation. MSDN. There's got to be a way that I can like go through menus. So this is about menus, check menu item, create menu, draw menu bar, get menu. Ooh, retrieves a handle to the menu assigned to associated window. Okay. 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 Highlight menu item. Did that take a menu? Maybe we can programmatically search through the menus. Hey, I mean, if we can programmatically enumerate the menus, then we'll just add that to our magic. Set menu item info, remove menu, modify a menu, is menu, insert menu item, get system menu. Enables the application to access the window menu, known as the system menu or control menu for copying and modifying. Okay, get menu string. For the specified menu item, get the state, get submenu. Retrieves a handle to the drop-down menu or submenu activated by the specified menu item. Okay, so that takes a wind menu. Okay, so we're gonna start blasting some of these off. We're gonna just see what happens. FN get menu. Wind, usize. What do you guys think? Is this gonna work? Print get menu of self.wind. Please, 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 please. That's a number. Since that's a number, that's good. Okay, so we can get menu. Then, okay, so that gets us. What menu even is that? So let's get menu string. Man. Get menu item info. H menu. Identifier or position of the menu item to get information. If it's false, it's the menu item identifier. Otherwise, it's a menu item position. Oh, accessing menu items programmatically. Okay. So I think what we're going to do is we're going to set that to true, and then we'll use item positions. So let's squeeze this little bad boy in here. Menu, usize, item, u32, by pos, bool, menu, info, mute. We're just going to say mute u8 for now. Is that a pointer to a pointer? Menu item info structure. You must set this to CB. Okay. What's this going to give us? It's going to be a lot of work. Size, mass, state, type, whether it's checked, submenus of it. Yeah, I think we're going to want this. Okay. This is a bool. Then this is going to take a mutable pointer to a menu item info. So H menu item by position. Then we're going to make a new repr C structure. Rust implementation of menu item info W. Struct menu info, I think is what I called it. Menu item info. Okay, we're gonna have CB size, U32, F. We got a mask. We're just gonna say size, mask, type, state, ID, sub menu, BMP checked, BMP unchecked, item data, type data. That's a pointer to a string. CCH, I don't know what that is. I'm guessing that's the number of characters in the type data. BMP item. Okay. So let's clean this up a bit. Doop, doop, doop. All right. I think we did that. Okay. So now we should be able to use, and then we're going to derive clone, actually just debug on this one because it's got a pointer in it. This is not happy with formatting right now. There we go. Press key, open menu. Okay, so we're going to let menu is equal to this. Assert menu is not equal to 0. We'll eventually do the correct error handling in a second. I just haven't figured out how I want to do this API yet. Menu item 0 by position is true. Menu item is going to be immutable. Let mute menu item is menu item info default menu item. And then we're going to assert that this is true. And then we're going to print this bad boy with some hex. Down here, we're going to need to add default, and we're going to need to change this then to usize. Okay, so this failed. Okay. So get menu item info does not seem to be working. So we got retrieves a handle to the drop-down menu or submenu. So what do? We did get menu. Doop 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 doop. So retrieves a handle to the menu assigned to a specified window. Okay. Maybe the submenu? Drop-down menu or submenu activated by the specified menu item. 0 base relative position that of an item that activates a drop-down menu or submenu. So let's see if we can do that. And that also takes in position I32. If it fails, it's null. So we're going to get submenu. Assert that, and then we're going to look that up from there, see what happens. Oops. Get submenu. Okay. Interesting. Let's just put this in here so we can see what the error is. The parameter is incorrect. Submenu 0. We can try false. No. Oh. Size is equal to take a genius to understand me. Boom. All right. Try into dot unwrap. Nice. Probably don't need the submenu thing anymore. Okay, so we're gonna get the 0th menu item, and that didn't fill in anything. What the hell? I mean, it succeeded, but like, surely something has to get filled in here, right? Let's get system menu. This is system. Okay, so I think the system menu is this menu. So we don't want that. We just want get menu. So we got the menu. Then get menu bar info. Choose information about the specified menu bar. Get submenu. Get system. Okay. Nice. Okay, so get menu item info. I feel like I'm confused why it's returning just zeros. It's we'll put this to false. No. Like, what if I just do some bogus number here? Like, I would expect that to fail. Okay, it did. Mute menu item. We can get submenu again. We're just gonna try this. Position was an I32. Let sub menu is equal to this menu. Assert the submenu is not equal to 0. And then we're going to look that up for submenu 0. Okay. Menu state. Maybe it doesn't have anything. Menus. Get menu default item. Get menu info. Let's see what this does. H menu by position. GDI flags. How it should search for menu items. Get menu string. Been superseded. Use get menu item info to get the text. That's what we're doing. If it fails, it's 0. Get last error. First find its size. First find its size by setting the size of the string to that, to null. Then calling get menu item info. The value of CCH plus 1 is the size needed. Then allocate a buffer for that size. Place a pointer in type data. If the retrieved menu is of some other type, that sets type data. Sets CCH to 0. Okay. Boy, that's tough. Get submenu, get system menu, get physical cursor position. Oh, that's a different API. Get menu string, get system menu. Highlights or removes the highlighting from this. Let's see if we can highlight a menu object. U32. Oops, usize. Highlight the menu item, either identifier or the offset in the menu item bar. And then there's by position, highlight. Okay. So, say position U32 and I'm gonna call this flags. We're gonna do highlight menu item in self.wind of menu, the 0th position, and we're gonna set OX 400 to do it by position, and then OX 80 to highlight it. So hopefully we will see which menu gets highlighted. None of them. None of them. We can make sure this succeeded. Oh! View is highlighted, but only when I have focus. Doop. So, let's see if I do a 1 here. If this highlights edit. Oh, now both are highlighted, but whatever. Okay, so I can probably get the, how do I click it? Load menu, loads the specify, is menu, modify menu, set menu. Set menu item info, command. Menu notifications. Set when a user selects a command item. Menu drag. Okay. Can I do that? Can I just send a wum command? Command item from a menu. So this is going to be if the message source then it's the identifier, the menu item identifier. How do I get the menu item identifier? Like, the get menu item info does not seem to be working. Am I like crazy? Because we're able to highlight it, so we know that it's like a real menu, but we're just getting zeros out. Menu item is that. Let's see if I add 1 to this, if it's happy about it. I just want to like make sure we're not getting some weird weird situations going on here. Try into U32, I think. I should be able to do that. No type argument. Yep. So we definitely have the size right. I mean, the function is succeeding. It's just, why are these all 0? Let's make sure. I mean, get menu item info dub. H menu item. H menu item by position. Menu item info W. And we did those correctly. Try getting item 1. Yeah, I've tried that. It does the same thing. It's just all 0s. It almost feels like an optimization issue with like Rust, but it's not. Maybe you can't do it for another process. Maybe you can only do it for yourself. There might be a chance that maybe makes a selection from a menu. The 0-based index of, okay, let's try this. We're gonna do a send message of menu command and then a handle to the menu. So this is gonna be self.wind, menu command, 0-based index, and then the lparam is gonna be the menu. See what we got. Yeah. I just want to see that little menu pop up. Send message. Yeah, none of these things are defined. Starting to go crazy. And post message. So we're gonna post that. And yep, it's W. So menu command, when the user makes a selection from the menu, 0-based index of the item selected, lparam is the handle to the menu. We have highlighted that menu item, so we do know, like, we know for a fact that the 0th position is the view menu. So maybe it's not 126, maybe it's WM command selects a command item from a menu when a control sends a notification message to its parent or an accelerator thing. Okay. WPARAM, menu, the menu identifier. Okay. Let's see if I can get the menu identifier somehow. Ooh, what's this? Releases a right menu button. No. Menu drag, menu command. Exit menu loop. Okay. Load to menu resource, is menu, insert menu item, get menu string, get menu item ID from a specified position. This menu, usize, pos, I32, U32. If the menu identifier or the item opens a submenu. Okay. If it opens a or if the specified item opens a submenu. Ooh, let's do this. Menu count. Menu count is this menu. Will that print 3? Yeah, so it's 1, 2, 3. So I mean, we can see what this does. First ID is this of menu. That's -1. So yes, that did fail, which makes sense because this says if it opens a sub menu, it won't give you one. So get menu, retrieves a handle to the menu, sign, blah, blah, blah. End menu, draw menu bar, create menu, pen menu. How do I pop it up? I could do the bounding rectangle and click on it. If the menu opens a submenu, it returns the number of items in the submenu. Okay. Retrieves a handle to the drop-down menu. Maybe you can't. Let's, so we're gonna grab the submenu, and then we're gonna do submenu 0. Should be standard. And let's see if we can maybe send to that. Menu item from point. Oh, this is cool. Menu item from point. So based on where, like a position, you can get the menu item that belongs there. That's kind of neat. Track pop-up menu. Tracks the selection of items. So I can try to do a WM command. So let's see if on submenu, we're going to take a look at submenu 0. So submenu 0 should actually give us a real thing. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I'm guessing the spacers are also fields. This time we have a 305. So let's see if we can get menu item info for that. We can't. So that seems to not do anything. So we can try and send a OX111, so a WM command. The W param we're going to set to 0. And then we're going to send the menu identifier for the 0 submenu field. So that should hit standard. Expected U size found U32. Yup. No. Menu command makes a selection from the menu. Gives you handles to the menu. So you can access the menu data in menu info. Gives you the index of the selected item. I'm guessing that's when you're hovering over things. I think. Oops. So here's what we can do. Because we're starting to struggle here. Let's do a get menu item rectangle. And we could maybe click it. So we could potentially get the rectangle for this and then actually end up clicking it. I don't know. And this wind usize menu usize item U32 PRC item. This is going to be a mutable reference to our rectangle structure. Returns a bool. Repr C struct rect. I think it's like left E32 top 32 right U32 bottom I32. Okay, and we're just gonna see if we can get the rectangle. Menu for 0 base position, mute rect. We'll assert this, and we'll take a look at what the rectangle looks like. And drive default, colon, copy, debug, default. Put a little dot in there. All right, so that looks good. So those are the positions of all the menu items. And I'm guessing that's relative to the screen. So I'm gonna put this like very far up in the corner. And now we should hopefully see, yeah, it's now left 3, 32, 42, 51. So that's gonna give the position of that menu. Let me see. Menu command, notify by position. That select items from the window menu are translated into syscommand. What's this? Ooh. Command from the window menu. Yeah, the system, that's this. Yep, close, context, help, horizontal scroll, min-max. Yep. Okay, so menu notifications. I'm kind of surprised that it's not popping up the menu when this happens, but it might not do that unless I have focus of the window. So what I'm gonna try to do is I'm gonna see relative to the client rectangle. Let me see if I can click on like 5, 5. So this is, I'm gonna try and do 5 shift 16 or 5. That's just gonna set the mouse position coordinates. And then we're gonna try and do a left click at that location on the main window. We're gonna see if that primary window dot left click, none. Not quite. Unless it's supposed to be at 2042, but I don't think so. Let's make sure my parens are good here too. Just to be careful, 2042. Nope. And 5, 5. I'm just double checking to see if my parens were bad. No, that doesn't seem to do the trick. Huh. Let me see if I can wm command send message. Pressed on the button. Send message click. Not what I want. Send message, open menu item. Blah, blah. So this was us. You'll need left button up, down, not set cursor. Properties of the W param, L param. Yep. up, down. So this is left button down 1 at this position. Really? Really? Do you think I... No, I definitely send it to the window handle. I don't know. That's notified by position. Menu command is sent instead. So menu command, when the user makes a selection of the menu, zero base index, a handle to the menu for the item selected. Just undoing this stuff quick. Okay, we have that rectangle. This is posting. Let's try 126. I'm pretty sure we've done this already. And we'll do sub menu. And menu. Oh, did that? That said it. Maybe it's because we have highlight. Let me, I'm just going to get rid of all these things because they clearly don't do anything, it seems. We're going to get the menu. So that doesn't work, and that doesn't work. See you later, Skipwitch. Man. Like we're... Enables the menu item, draw menu bar, destroy menu, delete menu, create pop-up menu. I don't think draw menu bar is what we want. Modify menu. Maybe I could do like modify menu and give it a like enabled, disabled. The breaks pop-up specifies that it opens a drop-down, unchecked. Nope. Displays a shortcut menu. Add specification. The shortcut menu. Handle to the shortcut menu to be displayed. Okay. I'm trying to click on a menu item. It's apparently an extremely hard problem. I don't know. Can I go through? Can I figure out? Sent to the owner of a drag and drop menu when the user makes a selection to request extended title bar information. This one has been destroyed. When a user selects a command item from a menu, when a control sends a notification message to its parent window, or an accelerated keystroke is translated. Let's see if this works. Translate accelerator. That contains process accelerated key from menu commands. Function translates that or a key down or syskey down message to a command message if there's entry in the table. No. Nope. Enter menu loop. False if it was not. That's not. Nope. Yeah, this is really annoying. Append menu, create menu. Like, I can enumerate it. Apparently, I can't get the items from the menu. Click Windows MSDN programmatically select menu item. Click menu and tray programmatically. Forward even uses that to display the menu. Blah blah blah. Send a command to it. Maybe I can do track pop-up menu. What is this? X and Y. Shortcut menu. Ignored. I'm glad that's there. All right, let's try. I guess we can just YOLO try this one. FN track pop-up menu, H menu, U size, flags, U32, X, I32, Y, I32, reserved, quinned, rectangle, which is unused, and a bool. So I'm able to like go through all of the menu things. Let's see what happens. H menu. We're gonna put this on a menu. Flags 0 0 0. Self.wind 0. We're just gonna assert that this succeeds. We're gonna see if that pops up the file menu, the view menu. Oh, that just failed. 0 more of these flags. Top of line. Left item only. Right only. No animation. Who owns the shortcut menu? This one receives all messages from the menu. Returns command. I don't know. Let's see. We can try and get submenu on menu and just see what this looks like. Nope. Must be 0. That's ignored. It can be any from your application. I feel like this doesn't work across applications. Command pop-up menu, not send. Blah blah blah. As list box, not the dialog. Nah. What's on activate? Maybe? No. Guess you want to trigger a specific action. No need to pop up the context menu. Just post a WM command. Matches the context menu item you want to select. You'll find that associated with the... Okay, let's see if we can look through the menus in Spy. Like, how do I look at... I don't know how I look at a menu. Process this. Next window. Caption. I want to look at the menu. Menu identifier should be part of the low word of that, which is the third argument. I mean, I can just brute force it and see what happens. We can just do post message of a WM command. Which is 111. We'll just do 4 and 0, 1000. Aye. So we're just gonna like see if we can click a menu item. No. Unless none of those were valid handles, but I doubt that's the case. Let's see what happens here. Yeah. Give me a command. wparam. Oh, wait, what? Oh, the lparam is 0. Oh, I've been doing this wrong the whole time. Yeah. Send the menu identifier here. The lparam is who cares. Let's see what happens. Oh, there we go. Woo! All right, let's try our fuzzer again. Let's boop. Well, that's just an instant crash. Well, apparently that is a thing. Well, shit. Maybe we just do this. Maybe this is all we needed. Maybe at the end of the day, this is all we needed. Okay. So we should be able to get, we should be able to now enumerate menus and then click the correct items. Oh my god. Wow, I screwed that up pretty bad. Man. Wow. All right, so now we can hop back in. We can see we can see what's going on. So we're gonna want get menu item ID. We're gonna want I think get menu, get submenu, and I think this is all we're gonna need to enumerate menus. So we're gonna start off by getting the main menu of the application. We're gonna like keep this around for a while. So what we're gonna do is we're gonna get the root menu, and then we're gonna do for menu in. Do we just do this recursively? Do we use a queue? Have you thought about turning on VODs? I think I should have VODs on, but if you ever miss a stream, I do upload them to my YouTube channel. So all of my stuff, I manually handle the VODs anyways. So if you go to this, you'll find like yesterday's stream, you can find right here. So this is the link to my YouTube. Okay, so I can get the menu, and then for menu ID and 0 dot dot get menu item, get menu item count from menu, print, we have menu this. Yep. What's going on here? Oh, I don't have calc open. Okay, so we got calculator. Okay, so we have 3 menus, 0, 1, 2. And then we'll have, we'll get the associated menu item ID, which is what we have to use for post message. This is going to be menu ID to get that from menu. So these all are -1, which indicates either it was an invalid ID or there's no, or it's a submenu. So we're gonna do open menu here. We're gonna take eSource main. This is now gonna take enum menus. Enum menus, and then recurse menu self menu handle usize. And okay, so what we're gonna do is we're gonna get the menu for the window, and then once we have that, we're gonna go through, then we're gonna call recurse menu on menu handle. Okay, and then this, we're gonna get the let menu let's see, this is gonna be menu index. So we're gonna, from the menu index, we're gonna get the menu ID. If the menu ID is equal to this, menu is a sub menu. So then we can do a let sub menu equals get sub menu of menu handle. And then we can use the menu index. Assert sub menu is not equal to 0. Recurse menu into sub menu. And then here we'll do, otherwise, we'll print we have menu this menu ID. Right. Incorrect close delimiter. Recurse menu. Yep. Self.recurse menu. Self.recurse menu. And menu handle. Where is it? Menu handle. Okay, so these should be all of the menu items available, and I'm guessing this is 0. This is 305, 304, 306, 307, spacer, 965, 303, spacer. So zeros, I'm guessing, are spacers. If menu ID is equal to 0, I don't know if it's safe to say if that's a spacer or not. Let's see if I can find space. MSDN IDM menu constants. Menu structures. I'm guessing that 0's the special menu, but I think we can just put that in our set and just ignore it. I think that's probably fine. So menu IDs. So we're just gonna ignore all those things. We're just gonna have a mutable hash set of I think these were U32s. Get submenu. What did that return? or I guess we want get menu item ID, technically. That returns a U32. So we're going to have a hash set. So this is going to be recurse into a menu item, a menu listing, looking for sub-menus. And then in this case, we'll do menu IDs.insert menu ID. Use standard collections hash sets. And then this will go through menu as a submenu. Get the submenu handle. Recurse into the sub menu. This is a, I don't know what to call this, like a menu identifier. Add it to the sets. And this will be go through each item in the menu, get the menu ID. Okay, so get menu for that, recurse menu. We can start cleaning up this code now. We can say if menu is equal to 0, return error, just this. So this will say get menu error. Then we'll recursively search through the menu. This we can do let ret is equal to unsafe get menu. And we can make this stuff none, unsafe, and then recurse menu, we can just return out that, and then we'll make recurse menu return errors as well. Doop, doop, doop. I think there's probably an is submenu that we should use. So let's see if there's a sub menu. Get submenu. Nope. All right, we're just gonna stick with what we have. So get menu item count. Let's see what this one looks like. If it fails, it returns -1. Menu count. Let menu count is equal to this. If menu count is equal to -1, then return out an error. Doop, 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 doop. Get the number of menu items. Go through each of the items, get the menu ID. And then recurse menu, we want to do question mark on. And then this needs to take another parameter, which is the menu IDs. Get the Windows main menu. Enumerate all window APIs. Let's see. Enumerate all window menus. And this is going to be enumerate all window menus. We're going to do hash set of U32s. Get the Windows main menu. All window menus. Return a set of the menu IDs, which can be used with a wn command message. Okay. If the menu is equal to 0, blah, 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 return out an error. Otherwise, recursively search creates the empty hash set. So this will be let menu IDs is equal to hash set new. And then this will take the menu IDs. And then this, if sub menu is not equal to 0, if it is equal to 0, Then this was a failure. Good. Okay, and expected that due to type, so we'll just do OK menu IDs. Boop. All right. Got a couple issues we just got to iron out here quick. 246. This expects a result now, which we want to do here. 294, can't borrow as mutable. Now we can. And result must be used here, and then we can print this. There. Why not use AFL? AFL makes no sense in this context. AFL is a file fuzzer, we're not fuzzing a file. Pretty much as simple as that. On the flip side, the point of these streams anyways is to write fuzzers and learn how fuzzers are created. So using AFL is kind of pointless even if we were fuzzing a file. We're trying to be more educational and learning how fuzzers work and how to develop fuzzers rather than just using tools that exist off the shelves, because if you use things off the shelves, you'll never really make progress. You'll only work in the wake of other people. AFL is great, though. Like, it's great for file fuzzing. It's still a terrible fuzzer if you have more than 2 weeks of time to spend fuzzing something. So I recommend that if you are using AFL for something and it's a long-term research project, you should probably look into making your own fuzzer or modifying AFL heavily to do what you need to do. So now we can do pubfn, click, let's say, how do I want to say this? I want to do like run menu item or like activate, use menu ID, self, menu ID, U32, IO result. Whoa, what's going on? 1, 2, 3, 4. Any reason I'm using Ruby? I'm not. I'm using Rust. And I'm using Rust because it's just the best systems programming language, in my opinion, right now, for this sort of work. Let's see. We're going to, this will be send a message to the window indicating that menu ID was clicked. To get a valid menu ID, use the member function. Cool. So that's going to use a member ID. By having more than 2 weeks to fuzz something, do you mean that, for example, some code you maintain versus auditing something else? I just mean that AFL is really only good in environments where you have 1 day to set up a fuzzer. AFL will probably outperform anything you could possibly do or come up with in 1 day of work. And it will probably outperform anything you can do, and I'm not saying you as you specifically, I'm using you as a general sense, but it will probably outperform anything a security researcher can do within 1 day to 2 weeks of work. But if you have 2 weeks of work that you can set aside to read protocol specifications, look into like fuzzer design and write your own mutators or generators or get a better corpus or inject in a different way, it's very likely that AFL would not outperform what you could come up with a little bit of investment. So obviously AFL is amazing in that, like, off the shelf, if you have something that just takes in a file, you can put in an input directory and you can probably find bugs right away. But in a situation where you don't, if you're looking for like harder bugs or you're looking at a more tried and tested target and you have a little bit more time to perform your research, or if you're looking at an internal company product, or if you're trying to find O-Day or trying to like write an exploit, basically if you have more time, AFL is probably not, you probably shouldn't put all your eggs in the AFL basket. AFL will never be a good fuzzer on a specific target. It'll always be a mediocre fuzzer on generic targets. And it's a fantastic mediocre fuzzer on generic targets. That is a very hard problem in its own regard, to be generically good at fuzzing. But if you have time to specialize a fuzzer to your target, AFL will likely just be a complete joke to whatever you can come up with. So here we're going to do unsafe, post message. It's really just a matter of specialization. AFL just flips bytes in an input corpus and does some feedback with coverage. It's an 8-year-old fuzzer that has conceptually been around for 20 years. It's very outdated tech, and it's not going to find novel bugs. Sorry. So we're going to send a command message, which was 111, if I remember. So this is sends a command to a window, typically sent when a button is pressed or a context menu is used, or a menu is used, item is used. What does fuzzing do on a program like Calculator? Well, I kind of assume nothing. Obviously the bugs that we get out of this are pointless. It's no fun. It's only for fun. There's no value of these bugs. They're not RCEs. You're not going to get anything out of it. But it's fun, and we're going through roughly what is done when you're writing a fuzzer. Like, what we're doing right now is so similar to many other fuzzers I've written, even though it is a silly target with no actual reward. It's still the same process. It's learning about your target, it's writing something initially, running it overnight, learning how your fuzzer performed poorly or better, making modifications to it, improving it, iterating, and making a better fuzzer. And we went from a fuzzer yesterday that found a bug every 10 minutes to a fuzzer that now pretty much immediately finds bugs when I look at calc. So, and we can demonstrate that in a once we finish up the last bit of this code. So we're just finishing up this function. If this fails, we're going to also send the, what was it? I'm just looking for message type command. Damn, this song is good. Command. Second field is going to be the menu ID. We're going to send a 0. And if it succeeds, we're going to return OK. And then if it fails, we're going to print this out. More specifically, we don't need to return here. And this is post message W error. Boop. Success. So we now have a way to enumerate all the menus. Then once we have all the menu IDs, we can then dot try into dot unwrap. Okay. So we're not using the RNG. We have a bunch of unreachables because we're not doing that stuff anymore. But now we enumerate all the menus, and we can throw this in now. We can say if rng.rand mod 100 is equal to 0, so a 1 in 100 chance of, I think we're just gonna enumerate the menu all the time. So the menus will change as the application changes state. Same for the sub windows. So we're gonna say enumerate menus dot, and we'll put the sleep back in. Actually, we didn't want the sleep, right? Yeah, I think the sleep is just hurting us. So we'll get rid of that, and then we no longer care about these because we just enumerate those automatically. So we'll do primary window dot enum menus. This equals this. And then we'll do a vec u32. We want to basically turn this into a vector so that we can index it. Hash set. Not collect from .iter.collect. What? Really? Pretty sure hash set. I guess I could do. Yeah, I feel like iter on this. Yeah, it just iters over all the types. Not be built from an iterator of those elements. Enum menus. Oh, yeah. That's a really confusing warning. Or a really confusing error. I think it's just because we were missing the question mark. And then we just need to do .cloned. And we should be good. So now we have we've iterated over the menus. Obviously, calc is freaking out right now, which is good. And we're going to close spy. We're going to close this. And we'll do let selection is equal to rng.rand mod menus.len. And then we'll do window.use menu ID menus selection. And specifically, we can probably just do this in one line. We can just do this. So this is get a list of all of the menu items in calc. Select a random menu item and click it. 1 in 100 chance of randomly clicking a menu item. And then we're going to make this mutable. And then we're going to have if rng.rand mod 100 is equal to 0. And we're actually going to go to 7f, which is 128, just because this is going to be a little bit faster. So this is a 1 in 128 chance now. Re-enumerates the window objects. 1 in 128 chance of updating the sub-window. So basically, we want a random chance that we like reevaluate the state of the window, because when we change modes, new buttons and dialogues will show up. In this case, we probably do want this sleep. We're just gonna put in a 50 milli sleep and gonna do that so we don't have to namespace it. So 128 chance of doing that. Every time we're gonna select a random window and we're gonna click on it. We're gonna see what happens here. Sub windows not found in the scope. Yep. Let mute this. Enumerate all sub windows. And thus buttons and dialogue text boxes. Such. Okay. And then primary window.use menu item. Okay. So now I'm going to go into 33. We just want to put a question mark on that. Virtual key code. Seems like we're not using that right now. We'll just mark that pub. Okay. So you can open up calc, and we actually might want to increase the frequency of those if we're doing 50 millisecond sleeps. But there we go. We just saw it actually as a menu item there. So I'm going to drop that sleep time down a bit. Let's see what happens when we get rid of the sleep. Looks good. So there we go. And we got a crash. We got an access violation in a field that we've never seen before. So we got a null DRF here. Let's try it again. Open up a new calc, see what happens. Bunch of good stuff happening. Bunch of fields starting to get very corrupt on the screen. Some rendering issues. So now we're at the point of fuzzing. Oops. Got the help menu to pop up. So now we're getting kind of to the point in fuzzing that we want to play around with these parameters here. And we could change this to like an F. So we have like a 1 in 16 chance. So this will be a little bit more heavy use of those fields. And we'll just see what happens. Nice. It'll keep popping up the help. So it seems like we're not hitting any crashes in this state. So I think the sleep actually might help us to some extent if we put in like a small 25 milli sleep. This might actually give time for the window to render and for some of the activity to happen. I got a mod. Oh yeah, I do. Thank you. Thank you. So you got the about, you got a bunch of stuff showing up. Invalid window handle. Yeah, so we're gonna start seeing the invalid window handles, set rust backtrace. We're gonna need to start making basically all of our things fallible because we're gonna start to see these things, when the window changes, we're gonna see that this stuff will kind of start failing. So I'm gonna do if let sum, or if let OK, sub windows is equal to this. Actually, we'll just call this ret. We'll do sub windows is equal to ret. So that is now failable. The menus I think should be fine. Use menu ID, we're just gonna ignore this. And then this one we're also gonna ignore. So now we're just kind of ignoring those errors such that it continues executing even if errors occur. We're filling in fields for those things. That's great. It looks like we're using a lot of the UI that we weren't using historically, which is good. The pop-ups aren't affecting whether or not stuff works. So this is looking a lot better. Is there any advantage to using Rust for this? Yeah, it allows us to work with Windows API and native code while still using high-level operating system primitives of like, or high-level language primitives like vectors and hash maps and dynamically allocated arrays and stuff. So it just kind of makes that a little bit nicer. We're gonna put that to 1 milli. There we go. Got to crash and delete history. Nice. Let's see what else we can get. I think this state looks pretty good. We're thrashing pretty well, it looks like. It's kind of annoying when these pop up. It's really annoying when these pop up. Come on. I'm just gonna move that to another monitor so we don't see him popping up. So yeah, it seems like sometimes it gets stuck in these states. There we go. We got a crash. Unknown exception. This looks like stack exhaustion, maybe. It's hard to say. We're potentially missing some like first chance exceptions. Yeah, this got a lot better today, didn't it? This got a lot better. Yeah, it just looks like a stack exhaustion in that case. So let's decrease the frequency that memory those menu item clicks happen, and let's see if we can enumerate the sub windows every fuzz case, such that we have a very fresh view of the screen at all times. Because I don't think we're bottlenecking on anything except for the rendering, but we're getting a bunch of good math in here. And here we got crash, delete history. I think we've seen this one before. So now it's probably going to be a matter of just throwing this into Mesos and letting this run for a while. because this looks pretty good. I mean, it's exercising a lot of the behavior. This is pretty good at this point. Dare I say so myself. Is this something you do occupationally? Yes. Yes, I've been doing this for about 7 years professionally and 12 or 13 years as like a hobby. So we see this in LDRF a lot. So one last thing that we'll want to get kind of thrown in the loop here is we probably want a decent chance of closing the window. Like we want a random chance of closing the window. Wow, there's some weird rendering stuff going on there. This is pretty majestic though. Pretty happy with this. This looks nice. I'm trying to like keep an eye out for anything that it looks like we're missing or not exercising in the UI, but it looks like we're doing a pretty damn good job of hitting nearly everything. So what have we seen? We've seen a couple stack exhaustions. This looks like this is definitely another stack exhaustion. My peak message. Yep. Help browser not opening enough. Oh my god, it's opening so much. So I could put this to FF and we can see like playing around with these ratios and tunables is really important to fuzzing of like, are we changing the window too much that we're not like getting a complex window state before we're immediately changing and resetting the window. So like when this number is lower, it seems we're not seeing the about menu as much. It seems like we're not filling in like the mortgage calculator as much. What makes you say stack exhaustion? The long call stack? Yep, exactly that. Yeah, I just see a long, call stack and then a crash in a place that a crash would never occur for an access violation. So I just assume pretty safely that it's, that is stack exhaustion. I could be wrong. So this is looking pretty damn good. This one's running for a while. Yeah, this doesn't need to be mutable. Now we can change this to a sleep 0. Is that a valid license? Yeah, of course it's a valid license. Come on, why would I be using some sketchy license? I ain't a sketch. I'm actually surprised it's holding up this well to this level of hostility, because we're not treating calculator too well. Like a lot of applications probably would not survive this. It's not the friendliest. So yeah, it's hard to say like what the good ratios are on these. We can set this to 1, which will basically be a 50% chance of like a menu change, and let's see how this works. Looks worse. Definitely does not seem to be rendering in the traditional way. See like overlapping numbers here and there, which is kind of fun. There we go. That's the delete history one. We know about that. And now it's just kind of a matter of letting this run and trying to find like the right states. That one crashed almost right away. I don't think we've ever seen this one. No, we have seen this one. R8, get template arg value. Let's run this stuff in WinBag and just make sure /Windows System 32 Win32 calc.exe. Now we'll get first chance exceptions just in case there's some stuff we're missing. Does it make sense to include parameters in test case generation? Yes. So basically now that this has gotten to like a pretty happy point, what I'll probably end up doing is probably end up logging these to a list of like things to do. It's kind of difficult to know what to do because you don't know what state the UI will be in. But I could potentially log all the activities. I actually think the menu IDs are fixed. Like, I think those are, like, relatively deterministic. So we could potentially start logging all the things we're doing and then start gathering coverage information. And then we could start, yeah, I mean, at that point, we could start trying to, like, do some feedback and mutation based on coverage and try and find some like really, really complex program states. Got those DLL loads. So one thing that we could do is we could actually turn page heap off. dflags I win32 calc.exe minus HPA. This will potentially speed up the fuzzing process a bit. And we'll restart it. Okay, it's no longer got page heap, so this might actually speed it up a significant amount, which might mean we'll see more bugs. So we know that one, of course. But yeah, it would be great if we would be able to like minimize some of the stuff down. Due to some of these state transitions, some things might be like really hard to minimize down. I am pretty sure that there is a bug in, there's like a double free in the closing of calculator, but we can throw that in there. Let's throw a WM close in our fuzzer. I think it's WM close. So we'll just want a random chance of sending like the friendly close message to the application. Sends a graceful exit to the window. Close, and this was 0010, I think. Yep. And then we'll just go down here. And basically, it's just this. Attempts to gracefully close the application. Close, no parameters, self, and then this will just be close. And we could write a wraparound post message so we don't have this. When I see repetition like this all the time, I just assume that I'm doing unnecessary code duplication, so we could clean that up a little bit. But this isn't too bad, so I'm not losing sleep over it. And we should probably actually make it do it. So we're just going to give a, I think like 1F is probably best for this. Whoa. I just lost my cursor in Vim. Oh, it's because calc crashed. Apparently the cursor goes away if calc crashes. That's a thing. That makes sense. So here we're gonna do and actually I do like having this on a random chance. I do like having a chance of using some stale data, because that will potentially allow us to maybe send a message to a window that doesn't exist anymore. So if prime, we're gonna do, we'll have like a 1 in 128 chance of regenerating the sub windows. Compute the sub window list. Chance of randomly closing the application. I think this is fine. This will be like every 5 seconds, maybe. It's hard to say how many iterations per second I'm getting, so we'll just do primary window.close. And that one should always succeed, so we can check the result on that one. So, yep, and we got a close, which was nice. All right, and then we can, we're gonna turn page heap back on. What's interesting is that we closed the application, but it seems to be stuck. Like, for some reason it won't close even though we gave it the command to close. But yeah, it does look like it closes after about 5 seconds. That was a clean exit with terminate process. So sometimes it hangs and it like never closes. But just having that close in the loop will be helpful to potentially find that use after free on exit that we haven't been able to reproduce. I don't know if key presses are going to be necessary as well. We've had a couple. We've never seen the CO bug reproduce, which is kind of disappointing. So, but yeah, this is getting to the point that I should wrap this up in Mesos and kind of start automating this process. So let's go do that. So cd dev Mesos, and then we'll do git status, git diff. What changes have we made? We made that context change. Source, what is it? Shared libs debugger source debugger context x. Okay, so the clen is no longer used, I don't think. Unnecessary unsafe block. 4 kilobyte align the context. Win7 compat. C pointers never used. 9 context all. 297. C pointer, the initial value is never used, so we can just set that to this. We can actually just do let C pointer is equal to that. Okay, and git diff. Clean that up. We have those durations. Kill requested is true. Loop forever. Okay. So we should be able to do cargo run. P. Actually, -- Windows System 32 calculator.exe. Win32 calc. Okay, so that should every 7 seconds tear it down and restart it. We're gonna need to change our GUI fuzz application to reconnect to the application. Apparently I'm doing this as admin for some reason. Declone dev mesos armder sq target cargo run win32 calc. All right, so that's good. I'm curious if that will. Okay, so when it restarts, we're losing it. So we just need to have this. We potentially need to just have this in a loop. So we could put this in like worker. And then fn main loop worker if let sum, or if let error is equal to worker, prints worker exited with this error. Should do the trick. Yep. And then we're just gonna put a sleep in here of about 100 millis, so actually 50 millis, so we're just not too spammy when it's down. So this will come online. We should connect. We're getting all those exceptions up. Not enough quota. We're not even seeing calc pop up. I might need to add like an even longer delay. I think it's still fine. I think it's still doing the business. We'll see what happens. So there we got the null deref. This is actually new. We've never seen this one. This is a crash on process keypad inputs, and another crash here on this set templates. So I need to, I don't know why postmortem's popping up right now, but this is a little bit of an issue. I think it's because I'm detaching from it. Yeah, I think when I do the, I think it's the way that I'm restarting the file, restarting the application, gvim source, libs debugger, source debugger.rs. Looking for a 7. And kill requested, terminate process. I think what I might want to do is just return from here. I just don't want that postmortem debugger to keep popping up. Which font is this for Vim? This is just terminal. Damn it. Why is this popping up? I could turn off the postmortem debugger. Let's see. Got crash. This. Remove breakpoints. Return out exception code here. That's returning from this loop. That's returning from run. SP source main.rs. So we return from run, and then we're getting the postmortem debugger to pop up. I might be able to just turn the postmortem debugger off. Let me find where that setting is. It's just the terminal font. Like, it's literally called terminal is what the name of the font is. Here's what we want. We want AE debug. So reg edit. Okay, so I want to go into HKLM, software, Microsoft, Windows NT, current version, AE debug, auto set to 0. I think we might be fine with auto set to 0. I think that's all we had to change. Calc up, running. And then what I want to see is I want to see crashes without, so yep, no postmortem debugger came up, no pop-ups happened, so that looks good. Okay, so I need to look into my crash formatter because I need to include the location of the crash. I don't know why that's not in there. Let me, something's kind of up with that. So we're gonna look at got crash. So this is get crash file name, pass the exception record. PC is equal to rip as usize. PC checks base, that exception code. There's that code. Nearest module offset. So you should have crash under code under this. For some reason PC is broken. Let me double check this quick. PC is this context.rip. Beep 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 beep. PC is 0. Okay. Well, that's not true. Context, get context tid, get context, self.context, get the thread context for this thread, context is this. And then context is mute unsafe C pointer. Context is that. Let me initialize context. Oh, that also fills in the context. Yeah. Let context is equal to this. And then I have to fill in the context all. Okay, that makes sense. That makes sense. So context dot, I forget what the field is. So context, context pointer, context flags equals context all, and then I need to put this back as thing at the top. Woo! All right, dir del crash del star.dump or del star.dump dir. Okay. That should be fixed now. And now we should actually get the PC in the crash name. PC is this. We can just get rid of that. We're just gonna double check to see if this is working. We just need a crash. There we go, we got a crash, and that looks beautiful. Exactly what I wanted. So this is telling me it's a null DRF at that offset. So del star.dump del. Okay, everything should be good now. Sweet. So copy fuzzer deploy dot gvim deploy dot bat, and then this is no longer fuzzer. This is GUI fuzz. Cargo build release, go into Mesos, build that release, copy the GUI fuzz, release fuzzer to Mesos, and copy that to Mesos. And we should be able to do this. Fuzzer. Yep, it's no longer called fuzzer. Deploy. This is called GUIFuzz.exe. Okay, and then we'll make a fuzz fuzz.bat, and this is just gonna do start mesos.exe -- Windows System32 calc.exe start goofuzz.exe. And we should be able to eject that and boot up our Windows 7 VM, and we should be in business. And then I'm probably gonna take like a quick 5-minute break to grab like a snack. And then we'll look into getting coverage up and running. So we'll use Mesos again for coverage. But this time I got IDA set up, so hopefully that will get us the trick. So, okay. So I should be able to just double click fuzz. Ah, crap. I gotta change that then. Oops. Okay. Yeah. Yep. Yeah. So we'll shut down quick. We'll remount that, and then I just have to use the cargo. I have to copy the cargo thing here to make sure that we get a static binary. Okay, and we should be able to eject and boot. All right, fuzz. Looks good. Looks like fuzzing is happening. Just wait and see those crashes come in. It's not even giving calc time to like pop up and render, but I think it's still probably stressing all the code. It's kind of hard to say, like, do we need some sleeps in there to give us some time to render? I'm not quite sure. Hey, calc popped. We have 2 calcs somehow? I need to disable the postmortem debugger. That's probably what happened. Come on. Stop. 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 It's out of control. Oh my gosh, stop. Chill. Okay. I get it. Good. HKLM software, Microsoft Windows, NT current version, AE debug, auto, set that to 0, and we should be good now. Some of these calcs are not exiting. Not quite sure why. We can look into that a little bit. Yep. 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 There we go. And now we just let it fuzz for a while. I'm gonna take a quick little break. I'm just gonna grab like a little snack and some water, use the restroom, and we'll just let this fuzz. I'll turn up the music in the meantime. I'll be back shortly. I'm gonna try and like organize this. But I will see you guys in probably like 5 minutes. I wasn't expecting to come back to art here, but this looks pretty good. This is normal, right? That's a healthy looking computer right there. Should I call IT? Something's not right. I think my calc.exe is having some issues. I like this. I'm gonna take a little screenshot of this. This is good. We'll archive this as art. Make a new, resize the yeah. Make this. We'll just let's call this one art.png. And yeah, it looks pretty good. We got 4 different crashes. It looks like 4 of them are related, 1 is unrelated. And I'm just going by, basically, if they're close in the address space, they're probably related bugs. Call them Microsoft support. I mean, this is just gorgeous. Like, you know, we started on this. What is this? This is we're about 4 hours in. Yesterday was about a 5-hour stream. So we went from really having no idea of how to fuzz calculator to 5 bugs in 5 minutes with a new fuzzer. I'm pretty happy with this. So we're gonna shut this down. We're gonna take a look at what we got in the treasure trove. I don't think those are null derefs. I'm a little concerned with the accuracy of that. Yeah, we might need to do a little force shutdown. Yeah, it's fine. It's just some error pop-ups. It's fine. It's fine. Look at that. I even got a clean shutdown. All right, let's take a look at what kind of goodies we have in the goodie bag. Notice that this one is significantly more memory. All right, we have a null deref on process keypad inputs. Okay, boring. We have another null deref on process keypad inputs in a slightly different location. Got another one. And a set current template. Okay, so we know that there are still some more bugs in there. We could potentially change some tunables. Let's look into getting some coverage going. So let's boot up my IDERs. You know what? I might have forgotten to install IDA. I think I copied it onto the desktop, but I didn't actually install IDA. I definitely did not install IDA in here. Okay. I'm gonna quickly install IDA. I'm just gonna blank the screen while I do this. I'm still here. Don't worry. I haven't gone too far away. Alright, copying to desktop, just doing a little IDA install. Alright, yep, this, yep, this, yep, 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 yep. Okay. Installing Python. Blah, blah, blah. How's everyone's day going so far? Pretty excited. This fuzzer's turning out quite well. All right. Okay, and sort by name and sort by yeah, whatever. All right, we're back. Doop. All right, so now you have IDA, and I'm just gonna grab the Win32 calc locally. We'll do some testing locally first. Win32 calc, paste it in here. And we're going to want the symbols for that. So symbols Win32 calc. We'll just grab those. Yes. Yes, indeed. Win32 calc, paste it there. Copy, paste, boom. And then IDA, we'll need the... What do we need for symbols? The VS2010 x64 redistributable, I think. Yes. Oh no. Did that get symbols? Oh, I think we're good. I think, oh yeah, IDA has their own PDB parser now. I forgot about that. So they probably don't depend on that. Okay. So, we've got this nice and processed. We're gonna go grab the meso generation script. Dev mesos, meso gen. Which one do I want? What does this do? This will IDAT using mesogen IDA.py. Okay. So we'll do this and script file IDA.py. I think that, yep, just auto generates the meso in place. And we should be able to grab this. Hop on over to here and let's see if that's working. So we'll do, I think this, yep. Oops, I need to do this way. Nice, it looks like that is working now. So let's cargo run. And we'll just do a -- print. So this is all the coverage in calc. So if we hit a button, you see like new coverage. I'm gonna turn off the auto exit that I have in right now on Mesos. Where is it? 7? I just don't want that to exit at all right now. So we'll just leave that as is, and now we can see what calc looks like for coverage. So this is just all of the, I think this is block-based coverage. So if I change, so hitting view got me 3 new blocks of coverage. If I go into standard mode, we get a bunch of coverage. We see some destructors get called. If I change to like this mode, we see those change. If I hit like clear, we get SQM clear bits, programmer mode. Let's see, 5. So here we have like the big num stuff. Let's see if we do like a rotate right. Do we see a reference to rotate right in here? Maybe not. Let's find a different function. So here I can grab, let's see if we can find the history. yeah, delete history, clear history, so we see the C calculator history stuff here. We could probably hammer the history stuff pretty hard if we focused on it, and we'd probably get some bugs there. I think that's where the use after freeze were. So we could try and see if we can go in there and like clear and delete history like very, very, very frequently. But yeah, just doing like random operations just is increasing our coverage. Going into grad modes, yep, turn on sci mode bits. Update radio buttons. Yeah, so it does look like we're getting the right coverage out of this, so I'm pretty happy. Cosine, sine. If we look at, yep, sine H, sine, cosine. So we're seeing kind of all the coverage that we're getting. And this kind of coverage tells us approximately what percentage. Obviously, the percentage doesn't mean too much. We really only care about the absolute number of coverage hit. So we can just, right now we're at like 5443. We can see what happens when we run the fuzzer. We immediately get a lot more coverage coming through, but I'm guessing coverage will plateau pretty quickly. So now it looks like we're going a pretty long time without new coverage. There we just got some remove trailing space, some different blocks in some of the send characters to display control. And then this is the destructor. So on exit, a lot of stuff happens. Came back online. Let's see. So yeah, it seems like, I don't know, it's hard to tell how much coverage we're actually exercising here. I'm trying to like pay attention to what operations cause like a lot of coverage to increase. We might want to switch away from using a random model and maybe more of a like exhaustive model where we like try all the buttons, or maybe try buttons that are regional to an area. Obviously, this is just calc restarting. Actually, calc just crashed a couple times there. Let's see what these ones are. So, process keypad inputs, process keypad inputs, process keypad inputs. So we know about those bugs. I don't know what the bugs that we had before, the crashes we had, which I might have accidentally deleted, which is not a big deal because we can just go get them back. Here they are. So we have this one, which is, this is in switch history. And this one is an actual memory corruption bug. Yeah, switch history. This is the kind of the teardown process. Destroy window and do exit on calc. So that's something that we'll want to see. And then the stack overflows. We've seen a couple stack overflows. I don't even think I have Mesa's configured to save stack overflows because it's just, who fucking cares. So these bad boys, we're probably gonna want to. We could try and drill down and focus on the history side of things and see if we can maybe focus kind of on the history switching and see if we can see the different ways that this bug can crash. This is the most promising bug we have so far, and I think in the meantime I should have, I don't know, I'm just trying to think through like how I would do good code coverage feedback. And I'm struggling to think of a good way to do that. Mainly because a lot of this is interaction based. So we could generate like a stream of events for calc to do. I'm not sure how deterministic it would be. We could take a look. So what do people want? Do you want to focus in on what we already have, or do you want to keep searching for more unknowns and trying to make our fuzzer better? Because both of them are important. Like, looking around areas that you already know there are problems in can sometimes result in learning of new things to look at. And of course, improving your fuzzer generically always increases the chances of finding complete unknowns. What do we already have? We have like 5 unique null derefs, 3 different stack exhaustion bugs, and 1 double free on exit that we've never repro'd, and then a uninitialized heap memory access as well. So, go for breath? Okay, I'm down for that. So basically the path that we have to go down if we want to start looking into getting coverage involved into the loop, we have to start figuring out how deterministic calc is. We have to figure out how reliably can we start up the calculator application, run some key presses or commands through it, and we'll see if the coverage is the same. And if we can reliably get the same coverage with some sequence of events, then we could probably start mutating based on those sequences and start looking for really dense, impactful fuzz cases. I do think coverage is actually really big here. So I'm going to get the fuzzer up and running here because we just want it running. So this is up and running. That'll just be fuzzing kind of while we are thinking about it, and we'll maybe see some new crashes come up, and that will potentially drive some ideas. But once you have a fuzzer that works, never hurts to just keep it up. So we have 5 crashes right now, all null derefs, and we're just going to keep our eyes peeled for some new bugs. So we're going to switch over to trying to do some coverage stuff. So the first thing I'm going to need to do is find a way to reset the state of calculator to the same initial state every time. Because right now we have calculator starting up in a different state kind of every time we load it. It basically leaves where it left off. And in that case, actually we can't have that return out. I think we have to have, I need to make one quick modification to this. I need to set the kill requested equals true here. I just need to terminate these processes as they come down, and then we'll just do our deploy. Good, off, up, deploy. Right, and then we can eject that. 2 files copied. Eject. Boot. And then we'll just have this up and running and churning while we're trying to add some coverage to this. So basically coverage is useless unless you're actually using a format that allows you to mutate on previous examples. So if you collect code coverage and you have no way of reproducing the results that you had, it's just useless because your coverage means nothing in the future because the past events don't indicate any success criteria for future events. So I'm going to try and move this to the side. Hopefully we'll be able to have good visibility of these, and basically we just want to see this count go up. Maybe there'll be 10 if we let it run overnight, and maybe there'll be more crashes that we didn't even know existed. So just want to keep an eye on it and make sure that new cases keep spinning up. We have a lot of duplicates coming in. It looks like a lot of the cases are ending up crashing. I do want to disable this calculator crash pop-up. That might eventually cause some resource exhaustion, but we'll worry about that some other time. Okay, so code coverage, or more specifically, calculator reproducibility. So let's go look at Procmon, which I think I downloaded, and I did. Extract here. We're gonna grab Procmon. I'm gonna quickly clean out all of these filters. It's on another monitor. I'm just cleaning it up quick. If image path contains win32 calc.exe, then include, add, apply, and then what else is there? There's the drop filtered events, clear. Okay. So now we got procmon. We can open up calc. And let's take a look at what registry keys it accesses. So we can see it opened up with history enabled in scientific mode with the basic settings. And basically we want to make sure that procmon always operates, that procmon always opens in the exact same state. And then every once in a while just remind me to like check on this, and we'll see if there are new bugs. It does look like we're at 6 now. Looks like we have one that was related to this kind of path as well. Good night, live overflow. See you around. Page heap flags. 130 calc. These are all debug sort of things. Loading stuff. Don't really care. Don't really care. Don't really care. MUI. Don't really care. I want like reg enum key, reg query key. I want like a reg save key or modify key. Use filter. That's image file. Execution options. Classes, input. I'm just scrolling through to look for something that really stands out. There's a chance it's a little bit more confusing, or it's like in one of these GUID things, but that's kind of hard to say. I'm looking for like a H key, current user, something with calc in the name. Like this. H key, current user, software, Microsoft Calc, window min height, placement, all of these things. I'm guessing is going to be everything we need. I'm just going to pop this key up over here. Copy that. Okay. If we take a look, Calc has a couple of these options here. We've got date time, we've got layout, we've got show history, templates, unit conversion, use separator, and window placement. So I'm gonna hazard that if we do this, I bet if we close it, this will probably come back. Yep, so we have this, delete it, yep. And then if we open Calc, it'll probably be fresh. It is, perfect, done, problem solved. We just need to remove this key entirely. So we're gonna take a quick look into where this key is located at, or how to do this in the easiest way. There's the cheating way where I could just like make a reg file, or I could do it correctly where I actually delete the delete reg key, delete registry key from the command line. You know, I'm not a big fan of doing like os.system sort of things, but in the case of something that's a one-liner, that would be really obvious what we're doing versus writing like a pretty complex thing that would require like 5 FFI bindings, some lookups, some like string conversion to UTF-16. We're just gonna do this. Sorry, guys. So we should be able to do this as an unproved user, and I'm just gonna see if we can just do this. Reg delete this. Yes, done. Easy. And now I just need a reg delete. I just need a confirmation. Forces the deletion without a prompt. Exactly what I want. Reg delete /f this invalid key name. I think that's fine. Yeah, that's fine. So we'll open up Calc. Good, fresh. Oh, is it? It doesn't like that. Maybe I need to put this at the end. Okay, unable to find the key. Open up Calc. Change it to programmer mode. Close it. Run that single command, open up another Calc, we're good. Okay, so this command should reset basically the state of calc to a known state. And let's check in on the fuzzer. We got a right high. That, my friends, that could be a big deal. That actually could be a very real bug. Any reason you're using Rust for the language? So, we'll take a look into this later. We'll put this on the back burner. Let's finish where we are. We'll just minimize this. God damn it, I want to look at this so bad. Okay. So, we're going to do use standard process command. And then we're going to do command new reg.exe .args this and this /f, I think it was, dot check output dot unwrap, and then return okay. Is there any reason you're using Rust? Yeah, first of all, it's my favorite language right now. Second of all, it's really good for systems level programming like we're doing. And third of all, it gives very high level constructs. So we're able to work with things where we're working with arrays and iterators and really simple conditions. It just makes programming so easy. Like, for example, if we were to look at this like enumerating child windows, I'm able to just, like, I call this Windows API, I pass an immutable reference to this window listing, I cast it back to a Rust object, and then I can just append a new object to that. And I don't have to worry about anything. I don't have to worry about any freeze. I don't have to worry about checking boundaries on array accesses. It's so easy. And the code quality that you get from writing Rust is much higher than that of C or C++, and I don't like Go. So that's why I'm using Rust. I also don't like scripting languages. Arguably, this could be done in a scripting language, but I would rather write Rust in this case. It's more preference. If I were doing OS dev, it would be a different conversation. I'd say, like, pretty much the only way to go is to use Rust. Check output, not on command. Yeah, it's not check output. I think that's Python. Rust. I think it's just .output. Command Rust lang. This. Yeah, it is just .output. If I'm not mistaken, this will attempt to run the command, and I just want to make sure. Okay, so then this will print. This will return an object that has like standard out, standard error in it, and we just don't care about any of those things. Yeah, so there's like standard error with this system was unable to find this, blah, 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 blah. If we actually ran calc and closed it, we would see that it successfully deleted it. So we're fine here just running this. This will, we'll make a comment, delete all state involved with the calc.exe process. Technically, we're actually going to want to move this command into Mesas, because Mesas is what we're using to launch calc. But for now, we can actually launch calc from here. We'll do command new win32 calc.exe.spawn.unwrap. And I think that'll allow us to continue execution. Yeah. So that fuzzer's up and running. I don't know why we got 2 calc instances. Did you say OS Dev and Rust is the way to go? Yes. I don't think there's any other language that's even remotely comparable to Rust for OS development right now. Not saying that there can't be, or there won't be, or that Rust doesn't have flaws, but it is by far the best language to do OS Dev in right now. Can we check out what the high right bug is? Yeah, we can take a look. Yeah, it's right there. Okay, so those are exiting. Worker exited with code is not good enough. Let's just do this, and we'll do if flat okay wins is equal to this. Sub windows is equal to wins, and close, and that should be fine. Okay. I basically just don't want... I want this to continue, so here we're gonna do if let sum if let okay menus is equal to this. Okay. I don't think we have anything that is failable at this point. Pipe has ended. I think that should be fine. Really? Spawn.unwrap, attach to calculator, enumerate the sub windows. Maybe we just need a tiny little sleepy boy in there. Just take a little nap. We'll give it 250 millis. Print spawned. I think there might be a calc running right now. So we've got, yeah, we do. Okay, calc. We've got no more calcs. We should now spawn. Where's that gone? 132 calc.exe. Where's that at? Let's just sleep for a long ass time. I just want to like see the calc window pop up. Okay. Maybe 250 is too short. Let's do 1 second. Okay. And then it starts fuzzing. Let's try it again. Cool. And then I just need to see what happens when it crashes. Checking on bugs. 1, 2, 3, 4, 5, 6, and then the right high. Looks like the fuzzer's still running, so everything's good there. Do you think the problem that Rust doesn't have a standard ABI will be a problem for OS dev? Not one bit. I never really got why ABIs were always such a big focus. Beyond, like, interrupts. Just doesn't really matter. Like, you can just extern C stuff if you need to have a fixed ABI. That's kind of always been my view. So I'm gonna do this if window.attach. Actually, I can do spawned calc. We just want to take a look at spawn should create a child, and then this will have try wait. I think exited with that, not ready yet, or attempting. Okay, so if spawned calc.try wait, if let okay sum status is equal to this, print calc exited with this status, return okay, check if the calc process has died. Yep, and we just need to make this mutable. Okay, that's gonna fuzz, and then once it dies, it should go away. But yeah, if there are ABI issues, you can extern C your stuff. I'm not sure if there's a way that you can kind of globally extern see everything. If there isn't, I'm sure you could make an RFC and have that added as a thing. But using okay, so let's see, where did calc go? So calc disappeared. I think calc is kind of stuck, so we're gonna have to end the process. It identified that it ended, and I brought a new one up, and everything's hunky-dory. Okay, so this does seem to work. The problem is sometimes calc does seem to get stuck when you try and close it. No new crashes. Sad day. I mean, this is gonna be a whopper. That's gonna be a doozy when we go in there. Okay. And it looks like calc just crashed. Nice. Okay, so we're deleting that. We're doing the same things. And what I'm going to do now is we're gonna modify our RNG. And we're going to make a new one called pub fn seeded seed u64 self. This is going to make a new RNG with a seed. Creates RNG with a fixed seed value. Put this in that. You should the right bug in Windbug. We'll take a look once we've done this last test. Once we've finally validated whether or not we can get some determinism here. I'm sorry, I like doing this to myself. I edge myself with bugs pretty hard. I've always done this. I don't know why. I think part of me doesn't want to kind of see the light and then stop a train of thought or like the process. Because like right now, I'm hacking it up. If we look at this bug and it's a crash in mem copy of copying from some like arbitrary address, the fuzzer is not going to make any more progress tonight. So that's kind of a reason I do it. I like sometimes will like put fuzzers up or I'll like set up a VM and then I'll like hide the VM and go to sleep. I fucking love doing that stuff. Nothing beats waking up in the morning to like new fuzz results. That's such a good feeling. So we're gonna make a new seeded RNG, and then we're gonna do 4 blank and 0 1000. Actually, we're just gonna 0 to 10, and then at the end we'll just return out. So we'll do spawned calc dot, I think, kill. Yeah. So we'll just kill the process after that. So we're going to do 10 commands. It's based on this seed, which is fixed. So it should do the same thing every single time. And we'll just take a look at kind of what state that ends up in. But I do think at this point sleeps are going to have to come into play. I think without sleeps we're gonna have noise in kind of in that sort of context. I'm really struggling to find words right now. 1 second. Basically, if we don't have sleeps, there will probably be a lot of noise in the like response time and rendering time of calc, and in that situation, we'll end up not really learning much about kind of like what the effects of things are, because a key press won't work if it's in a weird state. So we know that we've got 0 times 1, memory was set, and we have periodic payment set up. So let's see if we get the exact same thing. No, this time we had the help page pop up. So that's exactly kind of what I was concerned about. See, 0.1 fuel economy. Oh, that's because hash, we need to not use hash set. Hash set is not deterministic in ordering. B-tree map is. Basically, hash set uses like a hash, and the hash is seeded by a random value that's actually from the system, which means you have runtime non-determinism in your fuzzer itself, which then means when I made this iterator, where I created this vector, I was potentially getting in a situation where it was in a different order. So now it will always be in a sorted order. Okay. B-tree map expected. We want B-tree set. Why Rust uses a non-deterministic hash for their hashing functions? No fucking idea. Really stupid. Not a fan. Okay. So we got 0 times reciprocal proc. I don't know what reciprocal proc is. And then it cannot divide by 0. Let's see what we get. Beautiful. Again. Beautiful. Again. Again. Nice. Okay, let's do a little bit more complex. Let's bring this up to 100. Nice. So we're in fuel economy, 0 times 146, square rooted, and an about pop-up. Well, fucking look at that. That is awesome. That is awesome. Beautiful. Do you think we can deterministically do crashes now? If we just seed it and save the seed? Well, that's a treat and a half. Let's pump this out to 10K. We should see an about pop up. Oh, we don't. Okay, so that one ended up in an exit, so we'll put this down to 2K. I'm just trying to find a relatively long case to see kind of the state of calc. Okay, it opened up the help page. We have an about page and a 0. We just got really unlucky with that. Let's do a different seed. CMD. Oops. Stop. Oh, apparently I can't open CMD anymore. Python import random hex random dot rand int 02 to 64 minus 1. Okay, that's gonna be our new seed. We're gonna try this one out to 2,000 deep. Worst case scenario, we put some sleeps in there to give it some time to render, and that should decrease the noise. That one had an exit in it. Okay. Ah, that one ended up at 0 too. I need one that like we'll go to 500 just to make it a little shorter, and then here I'm just gonna print done fuzzing so that we know when it's done. Oh, it's like immediately done. Oh, it just queues up everything. You know, that might actually be an issue because we're not actively fuzzing the right state of the GUI. We might actually get better fuzz results with a sleep. Let's see what happens here. This is sleep 100 millis. We have 500. This should take 5 seconds. Or is this 50 seconds? Is this a 50-second fuzz case? Yeah, it's 50 seconds. I don't know, maybe 100 is a bit much. Let me just drop this down. I'm going to just drop this down to 50. This is now 5 seconds. So when we're doing code coverage, we actually want shorter, denser cases. So it's fine if we do fewer cases if we have more complexity in interactions. So 0 minus 7955. So what I can do is I can try to establish the baseline of determinism. So 0 minus 7955 and a multiply. And what I can do is I can pull down this sleep here, and we can see if it's still deterministic. And once it's not, so in this case it was, we were able to get the exact same result with no sleep. So if we got rid of this, we'll probably have no sleep entirely. Yeah. But I think when we have the mode changes, so here's what I'm gonna do. I think the user interaction can have no delay. But when we do a window operation, one of these bad boys, then we're going to sleep for 150 millis. We're going to give it a lot of, actually 250 millis. We want to give it a lot of time to like, actually 500 millis. I'm trying to think about like how long the animation takes. So this shouldn't slow it down except for when we do menu operations, which is fine. Now we can crank this up to 1,000. So we just give it a little bit of time when we do a window switch now, which is something that I wanted to do early on and I kind of forgot. Okay, so we have an angle calculation, a glitched out screen, and a 526 in there. This will actually be really interesting. If this reproduces, I'm going to be exceptionally happy. Come on. Come on. Came late to the stream. Basically, we're just randomly generating key presses and mouse movements and, like, UI interactions. Please, 526. And a glitched out screen. Okay, so determinism, let's say determinism is not going to necessarily be perfect at this point, but it will probably be passable. And passable determinism means that, like, yeah, it might not always repro, but if you have the same seed, you can run it through 100 times, and one of those times it will reproduce. Okay, so we can check on crash states. We can actually look at this right high. I want to shut down this VM anyways. So we'll do a quick shutdown. And we'll take a look at this right high. So now that we have done like the determinism test, we know that we can definitely head in the direction of doing like feedback-based fuzzing. A lot of things crash in there. All right, so we can mount this drive. We don't need that. We probably want that. Bring this open up my win bag. And we're gonna smash this in here. Oh no, it's a stack exhaustion. Yep. Sad. Yep. Yep. It's a write high because it's trying to write the return address of a call to the stack. Sad day. Not actually a real bug. I mean, it's a real bug. In fact, if I'm not mistaken, I think someone mentioned this bug the other day. So, all right. Sad day. We'll bring that VM back up alive, but now we are even more encouraged to correctly fuzz, right? I think this fuzzer is gonna go from mediocre to like next level pretty fast here. Okay. I got so excited with that right high. So excited. What a shame. What a shame. I thought that was gonna be like a mem copy or something. Because it's not in calc proper, so I was like, okay, what would calc be using? I don't know, some string conversion or copying. No, I mean, that's fine. This is the VR roller coaster. It's a rough life, you know? Oh, this did eventually display 526, 526, and then this. So we're gonna run this again, mainly because I want to see if we get this exact same thing. Controlled right to any address. Yeah, I've got a couple ideas of how we could weaponize a bug for calculator. I think there's a non-zero chance that if we were to find like a use after free or uninitialized memory use bug, that I think we could probably land it. So we'll see what happens. I'm just gonna wait for this to render. Say one way of doing it. Clipboard. Paste something into calc. Like copy your exploit into your buffer and then paste it into calc. Even though calc won't necessarily render and process it correctly, it will likely allocate. It'll probably query the clipboard API to see how big the clipboard is, and then get the contents of the clipboard into a dynamically allocated heap buffer. It's possible that they use like a fixed size stack buffer, but I find that relatively unlikely. If they use a heap-based buffer, that means we could arbitrarily control one heap allocation of an arbitrary size, which would allow us to potentially groom into a specific bucket that contains an uninitialized user use after free case. So there are not going to be many ways to get arbitrary contents into an arbitrary bucket. Since we're doing UI interaction, I think clipboard pasting is allowed for an exploit for this. But we'll probably just keep going down and down the barrel of quality. We'll start off trying to, like, if we do find an exploitable bug, we'll probably start off trying to write like a generic exploit that bypasses ASLR and DEP, which would be a pretty complex exploit. Given that we probably won't have an ASLR bypass, we'll probably drop that down to like a lower level, and we'll just say like it's fine if you like grab an address off the system and use that for NTDLL base. If that doesn't work, we'll keep going down and down and down until we eventually find a place where we can exploit it. So, is the clipboard part of the fuzzing? Right now, it is not, but I do think that would be some good entropy in there. Why are you targeting calc? Calculator is the application that you pop up when you land an exploit, and like you can prove, hey, I have arbitrary code execution and the ability to launch an application, which usually means you're outside of whatever sandbox you are jailed in. It means that you have clean, reliable control of execution such that you can get arbitrary code execution that can call a function correctly with parameters, which usually is a good sign that you have your foothold and your exploits actually landed. So finding an exploitable bug in calc and landing that would just be incredibly ironic. So it'd be fun. It'd be funny. That's why. We would pop calc from calc. And it would be like, yeah, it'd just be fun. That's it. In terms of why I'm streaming it, is we're learning a lot. We're writing an interesting tool. This tool is generically applicable. It enumerates all menus of your application and all buttons of your application and randomly clicks on them and types and does shit. So there's a relatively good chance that this would be just kind of a useful starting point for fuzzing other GUI applications. Even though fuzzing GUI applications isn't really useful, because almost any GUI interaction bug you would ever find is a useless bug, because if you have like arbitrary keyboard and mouse inputs to an application, you're done. Is there a reason you used IDA for code coverage instead of Intel PT? Yeah, it's just a lot easier. I have a tool that already exists, and I just was able to generate a file, and now I have coverage. Intel PT is kind of a pain in the ass to set up. It doesn't necessarily output in a format that I want to consume. Parsing the PT output is incredibly complex. I know that there are parsers for it, but they cannot do it in real time such that you can use it for feedback for fuzzing. I know people use Intel PT for feedback for fuzzing. It's not fast. It's not fast. The execution time is fast. When you factor in the parsing time overheads into it, it starts to become a pretty big issue. That being said, for single user land applications, it's fine because the parsing is relatively simplistic. But when you get into an OS environment, when address spaces are changing and you're switching between processes and modules are being loaded and unloaded dynamically, you need to log that in your event trace. You need to be able to parse potentially unloaded and code that has disappeared. Is IDA faster? Well, in this case, the code coverage has basically no cost. The code coverage only has a cost the first time the block is hit. After the block is hit, there is truly zero cost to the code coverage, and thus it's basically free. So yes, it is likely faster for long-running applications. The spin-up time is a little costly, but I could even make that persistent, and then it would be even faster. So, yes. I don't know why this hasn't rendered. Oh, clicking in a box rendered. Does it match? Yes. Everything matches identically. That is fantastic. That is incredible news, because that means we can now start working on a deterministic feedback-driven fuzzer. So I'm going to take one quick break to use the restroom, refill my water. I suggest y'all do the same thing. And then like 5 minutes, we'll get into Mesos. We're probably going to move this GUI fuzz into a library. Then we're going to pull that library into Mesos, and we're going to do everything inside of Mesos rather than having two separate tools, because we're going to start doing some complex interactions. So I will be back in just a few minutes. What is up? All right, so I just grabbed a little bit of food here too. Just reheated some leftovers. I was getting a little hungry. Okay, so we want to switch away from using seeds. So seeds are typically not too great to use with fuzzing. So we're going to switch away to using just a completely unseeded RNG. But instead, we're going to log all of the activities that we perform. Now, what's difficult about logging the activities is we need some way to deterministically mention what we did in a meaningful way. Music is really loud compared to my voice. Is it? Perhaps I was far away from the microphone, but it's showing that my voice is like at least 50x louder. Oh yeah. When I was away, I turned up the music. As louder than my voice? I'm kind of surprised. I guess I'm like talking. I'm at like minus 10 dB, and the music was probably at 0 dB. Actually, when I'm excited, I'm probably at minus 10. I'm probably at minus 20. So yeah, I guess it's probably like quite a bit louder than my voice. Sorry about that. Okay, so basically what we want to do is we want to log all of the things that we do that affect calculator. So this doesn't affect calculator. This doesn't affect calculator, but this changes our knowledge of Windows. This one does affect the calculator, so we need to log that. So we have a close event, we have a menu usage event, and we have a left click event. So we're going to make a enum fuzzer action, and we'll do a left click event, and this takes a handle, which is not good. This is going to be a problem because these handles are not going to be persistent between runs, so we can't replay with these handles. So we're going to have to find a way to associate the handle with some other piece of information that does not change between calculator runs. So we'll look into that in a little bit. Then we'll want a close event. No parameters there. It's pretty obvious what that is doing. And I think in the close case we can just break. Actually, we want to keep fuzzing. Then we have menu action. And this should take a menu ID, which is a U32. So these should be all of the different actions that we can do. I can't do default. During a fuzz run. So we're going to switch. Technically, we don't need wind bindings up right now. We're working mainly on our fuzzer. That's usually a good sign that you built a good framework when you've moved away from working with the internals of something and you're working more with what it was. So we're going to make a new mute. Actions is vec new. Create a new list of actions. Okay, and then all we have to do is everywhere we do these actions, we'll log them. So, and it doesn't really matter what order we log them in. So we'll do actions dot push close. So we'll push a close action there. In this case, this is a menu action. Yep. We'll call this menu action of, what was that? Menu ID of cell. And then down here, we have a left click action. Left click, I think I called it. And I think left click is the only one that's going to give us, we don't need to call it left click event, just left click. Left click on a handle, which is the window. And that's it. Now we're logging all of the actions we're taking, and at the end, we can just do this and print the actions. And spawn, blah, blah, blah. Let's drop this down to 10 just for simplicity. Close event. Whoops. Can you explain more about how you're using IDA for code coverage? Yes, I have a tool called Mesos that sets a breakpoint on every single address in a application. And it gets that breakpoint information from IDA or any disassembler that can tell it where blocks exist in the function. So there is the link if you are interested in Mesos. It has a decent usability guide and everything on like how to actually get it up and running. But yeah, it's mainly designed to be a debugging library that's capable of handling tens of millions of breakpoints a second. So it's just a high-performance debugger. But there's a command line app that uses the debugger as a library and kind of builds some of these common primitives of like gathering code coverage. Okay. Found reference to a window. Yep, so honestly, we can just put window here. That's fine. Does not implement copy. Window. Clone copy. Yep. Okay, so this is telling us what it did. it tried to perform all of these operations. So if we run it again, we'll see that the menu action will be the same. I need to seed it just so we can do the same thing, so we can see what the log looks like. Seeded leet. Actually 6 to change it up a bit. Okay. So here we have some operations on the window. I'm actually going to clear the screen just so we have nothing that we can potentially see anymore. So if we close this, we can run this again, and we'll see relatively similar actions, but the wins are differently. So the 975 is fine and stable. The close has no parameters, so that we don't have to worry about at all. But these windows are an issue. We have to figure out a way to uniquely identify windows. And I think it's a risky play. I'm pretty sure that the order that Windows enumerates them in is deterministic. And we're going to make a big, bold assumption of that. And we're going to do let cell equals this. And we're going to call this index. And hopefully this is the same. Okay, run it again. 36, 17, 33, 975, 18, 12, 20, perfect. Looks good. So let's pump this up to 1,000. We're gonna slightly modify the seed, and then we're gonna dump this into log.txt. Okay. So we're looking for an 813 E5, maybe a 3 minus. Close the calculator. Put this into log 2. And then I'm going to diff the two, and I'm going to see if at any point they had a different index for the operations they're doing. If they have the exact same information coming out, then we're going to be able to deterministically kind of set up the same environment every time. So we have two about windows open. We have an 813 E5. This looks exactly the same. So now we can do gvim diff log.txt log2.txt. And they are identical. Yeah. So if we were to do, we can even just do this just to be silly. Yeah. So they have the exact same SHA-1. What would that look like if they had different ones? Files too. Oh, it SHAs them together. Okay, so we have to do this. This. Yeah. Exactly the same output. So I think it's relatively safe to say that the way that we're logging the activities that we're performing are probably deterministic, and we're probably safe to do what we're doing, which is pretty sweet. So effectively now, what we want to do is we want to change this internal engine from doing random events to only doing deterministic events. Actually, anything that we do randomly here, we need to have a action for it. So even the window enumeration could potentially change the state of future things, so we need to log that. But everything else, I guess APIs can fail at different times. Unlikely. Not too worried about it. So here's what we're gonna do. We're gonna switch around. We're gonna move this fuzzer into a action performer rather than a generator. So this is only gonna perform actions. So we're gonna take actions is gonna be a reference to fuzzer actions. And we're actually going to make this take a mutable reference to a vector. Because we might do mutation in here. I haven't decided how I want to lay this out yet. So this is going to be perform actions. Actually, you know what? We're taking a immutable slice. So we have all of the actions. Delete the state. Spawn a new calculator, create an RNG, which we don't need anymore, attach to the calculator window, good, enumerate all the sub windows, perfect, and now we're going to do for action and actions, oops, and we're going to copy it. For action and actions, we're going to say match action. If it's a left click operation, then we're passed an index. And in that case, what we're going to do is we're going to click on a GUI element. I need the window from that. This. So we're going to look up the index of the GUI window, and then we're going to left-click it. I think that is it for that. For close actions, these are simple. We're just going to do the .close method. Okay. And then for... we need the last one. We need menu action. ID. Doop. And this one, we need to... I guess this one's actually doing the lookup of the menus. So get the primary Windows menus. We're not doing random. We're just taking instead of cell, menu ID. Okay. Actually, we don't even need that. Boom. That works fine. We don't need to actually enumerate the menus. So then this is going to be, we're going to call this generator. And the generator is going to be a little bit more complex because, well, I mean, it's exactly what we had before. But the reason it's a little bit more complex than this tiny amount of code is we need to dynamically query and find things on the window to click and action with. And that's something that we can't really do. We can't write a generator that generates a vector of these things to do because we don't know the valid menu IDs and indices of things. But we can make a set of these after a couple independent fuzz runs, and we can probably find a middle ground. So that's probably what the direction we're going to head is. So we're probably going to learn all the different things you can do in calc, and then we're going to make a new generator from that. So this is going to be a vector of, and I need to match on this fuzzer action. This is exactly the same. I'm just going to copy it for now. I don't like copying code like that. It can be kind of scary at times, but whatever. Okay, so then that's going to do a done fuzzing, kill the process, return OK. So here we can get rid of the loop right now. Generator. Exited with error. Yep, and this has to be a result box denier. Yep. Let mute actions spec new log of all actions performed. Generator, good. And this needs to return actions. We'll just print this here quick. Unclosed. Doot 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 doot. That. Yep, we need an RNG. In this case, we do need an RNG. What else do we got? Unclosed. Really? Where are... That's 16. Oh, in here. Oh, yeah, definitely. We'll move these to this side and try and reformat. There we go. Okay. This wants a result. At the end, we do this. So basically, click on a random element, close, perform a menu action, enumerate the sub-windows, and this one needs a vector 83, 83, 83, 83. Done. Okay, so that's kind of in the generator mode where it's going through and just trying random things. And that's going to get it into different states, and then we now have this log of all the things that were done to do that action. So let's do if okay, actions, then we'll do perform actions. Oh shit, this is a Hollow Knight remix. So I want to see it basically do the same thing twice. So I'm going to try and watch for the state. Actually, I need to, I'll add a print all done. Actually, yeah. Print all done. Sleep duration. We're going to sleep for 5 seconds. And then we're going to do print performing same actions. So basically, it's going to go do some random thing, and then it's going to recreate that thing by running the exact same actions. And we're going to see. We're going to see what happens. Is it waiting after each animation? Kind of. Oops. Okay. Okay, so there might be issues with this method. 1 second, taking a bite of food. I'm basically switching the window enumeration to being a constant thing that's always done. Otherwise, I'm just too concerned with potential issues, so we're going to get rid of that random chance. Oh, it's because we don't have an event for when we enumerate sub-windows. But I don't think perf is a huge issue on our side, so we're just going to enumerate the sub-windows every time, such that we are able to always do this. This could honestly make it less deterministic if the windows are animating and changing a lot, so it's hard to say. So sub-windows is equal to enumerate sub-windows. Go through, perform a left click. If we look up above, a left click implies that we enumerate the sub-windows, grab the one of that index and do a left click. And then menu actions should be fine. We don't have to actually enumerate the menus. I can tell Europe is waking up. More people showing up. Welcome to the party. Just trying to find bugs in calc. All right, let's see. Yeah, it's the same, right? 132. I'm gonna need to screenshot it when it does all done, just so I can actually compare them. It's an all done. We got an about tab. Okay. Trying to open paint. Oh boy. Huh. Maybe sometimes the window listings are different. I might need to put some sleeps in on the left clicks. Yeah, it's kind of rough. I think that one closed calc. This is a bad way of doing this? I don't think it is. I think this is a perfect way of doing this. All right, I think we're gonna call this close enough for a repro. It's not gonna be perfect, but you know, we'll take what we can get. So I don't want to go like too crazy. I can also throw this in a deterministic emulator and just make all our problems go away anyways. So okay, we do need to fix this one panic at 36. Basically, we're going to change this to if let some window is equal to subwindows.get index. This basically makes it failable, where now if it's an out-of-bounds access, we just won't perform the operation at all. Which, yeah, it's not great, but I don't want to put sleeps in here. I would rather have to run it a couple times than have to put some sleeps all over the place. These sleeps we can change to 250. Actually, we'll leave them at 500. It's fine. I don't want to change variables that we just kind of got comfortable with. Okay, so now we have a generator. We can kind of mutate, start up calc, do all this fuzzing. So we're going to want to put this into a library now, rather than an application, such that we can import some of this information into Mesos. So we're going to do a move source main.rs, source lib.rs, and source lib.rs. Oops. Go build. Should be good. Did that not open? Yeah, it did. Okay. Set GFN terminal H16. So we're gonna mark these public. Pub. I'm gonna make this public. This public. This goes away. This doesn't need to exist anymore. Cargo build. Okay. Spawn calc 25. I guess that's fair. We will no longer be spawning calculator on our side, so we're gonna get rid of that spawn calc stuff. We're just gonna attach to it directly right away. Spawned calc. That means we also get rid of this. That. We'll need to add in like a kill detection, but we're gonna do that specific to the debugger that we use. So at this point, we have kind of this GUI fuzz library, and we're gonna go in, and I'm gonna make a copy of Mesos specifically for this project, which is kind of the way Mesos is designed to be used. It's not designed that you like use Mesos as a something that you're like forking and maintaining. Just make a fucking copy of the folder. So we're gonna throw this in here, and we're just gonna kind of reuse everything that Mesos already has. Blah blah blah. We'll need to change this to pull in. I think we want to do it at this level. Yeah. So we're gonna pull in GUI fuzz, which is path equals dot dot slash GUI fuzz. And now we're gonna do everything in Mesos. Okay. So we've got that built in with our GUI fuzz stuff. So now what we're gonna do is we're gonna kind of reduce the space of, we're gonna kind of reduce the amount of space that we allocate towards the command line, and we're gonna open up another Vim window on Mesos. Okay. So this goes through, right now we just have it spawning this process every single time. We load up the Meso file, we do all of that good stuff, and then we run under the debugger. So what I'm gonna wanna do is I'm gonna wanna grab the command stuff, and I'm just gonna whack it in before we spawn the process. So I think everything before here is just parsing command line, so we can ignore all of that. And then we'll delete the register keys, spawn the process, register all these handlers. I don't think we need this, do we? Oh, we do. Okay. And that's going to go through and kind of watch everything. So let's see what happens. Windows, System 32, Win32 calc. Nope. All right, you just don't have command in the namespace. Okay, so that killed calc, and it should persist with those reset options. Yep, so that is working as intended. Now the next thing is going to be, I guess we're gonna spin up probably a thread here that's gonna perform these actions. And then we're just going to kill the thread when everything ends. So we're gonna do let thr equals standard spawn. So we're gonna create a new thread here, and the thread is going to, we don't need to extern create anymore. Maybe we do in this version of Rust. I don't know if I updated the Rust version. We're gonna pull in GUI fuzz generator. Actually, we'll just pull in everything from GUI fuzz. Yep. I need to change that in the cargo toml to use Rust 2018. Okay, so this is going to create a new thread, and we're just going to do generator in here. And this is going to standard thread. We're just going to sleep for 1 second in here. And then we'll run the generator, debug forever. When this completes, we will do a third.kill. Oh, actually, is there not a way to do it? I feel like Rust might not have a way to kill a thread. So we're going to do thread, spawn, join handle. Yeah, there's a join. Okay, so we might have to just do join dot expect failed to join to thread. Then this will give back the results of the generator. So genres, and then we can print this out. Break. Dyn error can't be sent between threads. That is true. So I'm just gonna do an expect error on generator. Okay, yep. Genres. So this should hopefully allow us to, yep, that's gonna run. And then eventually, yeah, so what's happening here? Valid window handle, so debuggity exited. Then we got an invalid window handle here. So we're gonna say if sub windows dot is error, gonna return okay actions. Basically, we're gonna break the fuzz loop if we're not able to correctly enumerate the sub windows. I'm also gonna move this code above everything else, and then we can unwrap that here. Sub windows. So if it's an error, return out the actions, and we're just going to use that as an indicator that that the window is gone. So we're doing random stuff. Okay, and then cool. So that exited, and then this, I guess we want to be an infinite loop now, and we want to only exit based on when the debugger exits. So I'll run forever until it no longer can successfully enumerate the windows, and once that happens, the thread will exit, we'll join with the worker thread, and then now we have all of the inputs that were used to create that case. So now we need to associate inputs with coverage information. So I forget where I put coverage. Lib debuggers source. So coverage is in a hash map there. Dot coverage. Breakpoint print, which you don't want. Sync complete, self-coverage length. Yep, okay. So we're just going to get access to the coverage database, which is keyed by PC. So we can go through all the PCs, and then we get the module offset, and then the symbol offset, and the frequency for that thing. So frequency is another mode that Mesos can run in, where you have it count how many times you hit each instruction. We pretty much never have it in frequency mode. It's kind of useful for debugging and some very exceptional fuzzing cases, but typically you're better off just kind of leaving it in the one-shot mode and building that coverage information. So now we can say let mut coverage database is equal to hash map new. So this is going to be the global coverage database. And let's see. And we're going to scale this out to use multiple threads too, because we can now. Coverage database, we need hash map. Okay, we got that, which is good. Then what we're going to do is, after the debugger is ended and we have got the results from the generator, what we can do is we can go through and say blah 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 for, I think I want to unwrap that. It was for PC, and then module offset symoff freak in debug.coverage.iter print. And I think we only care about the symbol and offset. That's what we're going to look at here, so we can actually just man, that's doing some weird scrolling. I mean, technically we just want module offset because it's cheaper. Because these are arcs and we don't have to make copies, so it just saves some in-memory space. And it has the exact same information. We'll just have to kind of process it out into different information later. So now what I can do is I can say coverage database. This is just going to be hash set, actually. This is going to be a hash map. This is going to be a hash map of keys which contain arcs to strings, which is the module name, followed by the offsets into the module. Then that element, so the key, is going to point to a usize, which is going to be an index into the input database, which is going to be here. And this is just going to be a vector. So this is going to be a vector of fuzzer actions. A vector of fuzzer actions. Okay, so then down here what we're going to do is we're going to go through all the coverage information that we get. We're going to do a global coverage dot. We're going to move this over here just so we can see a little bit more temporarily. Oops. Okay, so where are we at? This was coverage database, input database. I'm going to call this coverage DB just because that's what I am used to for muscle memory when coding these. So I'm going to do if insert if the coverage database does not contain module.clone offset. Actually, we can just do this.